Good morning. Hello. Happy Tuesday. How are you all doing today? We are going to be continuing on with the Docker course. And if I remember correctly, we're going to be working on reviewing the articles and recording videos for them. So that's going to be a lot of fun. So let's go ahead and get ourselves set up here. Albert, hello. How are you doing today? So we got our Docker course. We've got all of these lovely articles. Uh, Right, so last time I reset everything. So we can now do check marks when we review them. And what do we want? How do we want to do for videos type? We put the videos inside of the course. I need to record them first and then I upload them, then I put the videos in. Yeah, so that's gonna be a thing. You're feeling light. You just spent €250 for a 2 TB SSD in your laptop. I mean, that's pretty good, right? And 2 TB is always really nice to have. So, yeah, like if you haven't had like that much space before, it's pretty freeing. You can basically just do whatever you want. And I'd actually just started feeling space on the primary SSD that I have on my desktop, but I have a secondary disk drive that so far I haven't had to delete anything on there, but I'll probably get to that soon. I'll probably be getting that soon. Okay, you had 1 TB before, and you now have so it's an extra one, so you have 2 disks. Oh, that's even nicer. I really do enjoy having a secondary disk drive that I can fill up because having having a second disk drive is really nice simply because you don't want if you fill up the primary one that your like operating system is on, everything starts breaking, right? Like whatever the version of like swap you have, wherever memory is going, wherever your virtual memory is, what swap, whatever that is gonna cause problems if it fills up. But having a second drive fixes that entirely. Next upgrade will be RAM. 16 gigabytes is not enough. Yeah, I'm right there with you. I tend to max out memory. Uh, for a lot of notebooks these days, they solder the memory into the motherboard, and it makes it really hard to upgrade. If at all, like usually you have to go with like external memory, which is not cool. That doesn't work very well. I do know some people that have used external video cards with external video card memory, and that seems to actually work out pretty well. They're able to play some interesting advanced games on really tiny basic computers. So I guess like it the use cases are the most important, right? All right. So today this is what we're going to be working on. We're going to be working on reading through the articles that we have, and then we're going to switch over and record a video on it. And we're going to create a, I guess, I don't really know what else there is to talk about it. We'll record the videos. I'll rename them on the Windows side because that's where they get recorded, and then we go from there. I'm already recording, so I guess, I don't want to necessarily lose the recording, so what I probably need to do is just mark them. So I basically just do the thing. This will be the first time that I'm going to be like extracting these recordings from the videos, from the VODs essentially. But I am recording the VODs at what I'm trying to do is like lossless, not lossless. What am I recording at? You can put up to 64 gigabytes and use this laptop for dev mainly. I mean, for me, I like to go maximum memory. That's just me though. And I have some extra use cases, right? I am editing some videos. I am going live sometimes. Like this MacBook Pro I got because I also can go live from it and stream. So having some extra stuff is really nice. It also has an RTX 4050. Oh, the RAM is upgradable. That's really nice. Yeah, so I personally like to max out with memory whenever possible. And that's the combination old sysadmin in me and the person who just does a lot of stuff. Like I like to have a lot of things open. But okay, let's see. Where are your settings for recording? So in my recording, I am recording quality is indistinguishable quality, large file size. I do have simple output mode though, so I don't really know what that means. Everything else should be perfectly fine. It's audio track 2, which I believe I hope my voice has been going on track 2. Otherwise, all the VODs are going to be useless. Let's see, Yeti mic is 1, 2, 3, 4, 5, 6. All of them get the mic. Okay, cool. Hugh, hello. How are you doing today? RAM is upgradable, so not a Mac, not a Dell, not a ThinkPad, right? Like all of those are not upgradable anymore. Like all the major brands have switched over to the exact same system. A Creator laptop. Now the Framework laptop, well, I think it depends, right? Like the ones I've had recently, you couldn't really upgrade them, right? Or maybe am I thinking about the what's the one that everybody loves these days? It's not the Pro model. It's the Air killer. It's like their version of the Air. That's the only Dells that I've really liked. And they're now the same price as the MacBooks too. Oh, I forget what their name is. What the model is. But those ones I'm pretty sure you can't upgrade the memory on. And I also had another one, a Pro one, in the past, and it couldn't upgrade the memory either. They had soldered it on to the board, which was the same thing that Macs do. I mean, it's something that we see all the time, right? Is like Apple does something and then everyone else starts following it. Everybody makes fun of Apple for doing it, and then everybody else quietly starts doing the same thing because there was a reason why Apple had done it. I always find that that's really hilarious. And isn't that's really the reason why Framework is so popular right now? I guess so popular is maybe a questionable thing. Let me see. Why did that catch you by the mod? Huh. AutoMod caught that for some reason. I don't. Oh, because Dell support. It's Dell.com is perfectly fine. It's so it's Nightbot is the moderator, and I have links turned off because we've had some people come in here and put links to extremely bad places. And so it auto deletes the message, but it lets me know about what it is, so I can still read it. So I can go in and where's the spam protection options here? Adele.com is fine. So I'll enable that domain. And then there is a link in that quote. Go to dell.com/support. So here is what, wait, can I not? Okay, there it is. Here is the quote that Hugh tried to put in. So I have the last Mac I'm going to have for the last time, so I don't exactly care what the answer is, but can I add more memory to my Dell laptop? Go to dell.com/support, identify your Dell computer, and continue to purchase the memory. Okay, so, oh, XPS. It was the XPS, I think, that you can't do it. Which is also the notebook that the most people that I know who have had them like it the most. So I don't think all of them support it, but I think some of them do. All right, so all right, let's go through this. So first of all, the way I like to do this is we're going to review the article, just reread it, make sure that there's nothing that we need to change. Also, I want to run yes, before I do anything here. Buffer close you. Let's sure, go ahead and run. Macs with the new MX chips are really nice. A few years back though, they did not actually work with Docker. Yeah, so what happened was they updated, and then Docker was forced to run in Rosetta mode, which basically is it's pretending it's virtualizing. It's like a virtual machine behind the scenes that's running Intel on the MX. This is the exact same thing that happened when they switched to Intel from PPC too. And they Docker didn't really work. And so at the beginning it didn't work at all. And then eventually it worked, but it was extremely slow. And then eventually Docker was like, okay, I guess we need to figure this out, and then made it work fast. But yeah, I do remember the initial ones were like, eh. And I waited for a long time to get the Mac to make sure that it worked with that kind of stuff. All right, what did I do for my my spell check? It's iSpell, something like that. Yeah, iSpell. Okay, so if I do iSpell, yeah, it was a problem for the first year, 2 years or so. Okay, so whenever a word is found as a dictionary, blah blah blah. Okay, so I want to. Okay, so we have our commands. Oh, but this, I should be able to tell it to replace without creating the backup, I think. Because I have GitHub. That's my backup. I like how they're like, here, common flags, but like none of that really helps me. I need to see the help here. Wait, these are just the commands inside of the... Oh, if the dash M switch is specified, a one-line mini menu at the bottom of the screen will summarize these options. Okay, nice. So dash M. If the L flag is given, the specified number is used as the number of line. Okay, I don't think I need that. Yeah, so first I'm gonna do is, so we previously in previous streams we wrote all these articles, right? So now what I want to do is spell check the articles, make sure that they're, you know, they're good, because I did write them in Helix, which doesn't have a spell check built in. And then we're going to reread them, make sure that they're good, and then we record a video on it. And so we've done this in the past, like for a few different times. It's good. And let's see, I don't think, yeah, okay. Delete the backup file after spell checking is finished. So I can do a dash X. So I want the dash M and the dash X. And that's it. Okay. So we're going to do ispell dash M dash X. We're going to do, we're in the Docker for web development. This is the installing Docker. All right. So first, Ubuntu. Okay. So I don't care about that one. So I want to either accept it. I don't want to replace the word. Except the word, this time only a space. Oh, so this is probably, put it in my private dictionary, so capital I. And that's accept it. Okay, so no real spelling mistakes. So we're good to go. So over here, I want to go to definition, and we'll read through this really quickly. Installing Docker. Docker is easy to set up and install on our computers. If you have a Mac or Windows system, then follow the instructions at the Docker getting started. So if I let's verify that this is going to where we think it's going. Okay, it is. If you have a Linux system, you can just install the Docker engine without Docker Desktop directly. Here are the instructions for installing Docker engine on Ubuntu. Okay. There are also instructions for other Linux repos like Debian and Red Hat. Once you have Docker installed, you can check to make sure that it is running with the command docker image. If you have an error like cannot connect to the Docker daemon at Unix users Berserker, blah, 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 is, yeah, okay, so this is where it ends. I don't want that new line there. This is all one line. Okay, that's good. Then Docker is not running yet. Make sure that Docker is set up and running before continuing on. If you get output that looks like this, then Docker is up and running on your system. Okay, so that's good. So now I already have this installed, so there's not really much for, like, I can't really install it again, but I think we'll just go through it and like, hey, this is where it is. So, what does that mean for us? I want to, let me bring up all of the things. And I want, do I want like a start, like a window or something? I'll probably put that on like we'll have like a getting started something, and then I will, we'll go to here, getting started with Docker. We'll make sure, okay, you can download for the Apple chip, and then if it doesn't auto detect, okay. And then I will want, so I want to use Alacrity for that. Probably not. I think that that's going to cause more confusion. How about my iTerm? Okay, I think this is going to be good. It'll be nice and simple. And we can do Docker images. And we have a ton of images. Okay, I am going to want to just delete all of these. How about Docker? Yes. Okay, you're part of, oh, you're part of that Docker Express CRUD stuff. Okay, so you're down. That means I can do a Docker remove Docker PSQA. Oh, that was the only thing left, I guess. Okay, that's good. We can do Docker RMI. Docker images, Q. Delete all of those. Okay. What do we have here? Docker RMI. Okay, these are based upon the same ones. That's the problem. So we'll start with Express CRUD, not dive. Latest. Oh, now it's Dive Express. Oh, because you don't. Oh, weird. Because you don't have a. Okay, so I have to do testing. Then you just have this one. And we'll use the image ID. Okay. Now we'll actually see this. Excellent. All right, so things for this, we're just going to talk about where to go to get Docker, to install it, to make sure that you want to install it for the right chip that you have, and then also that's on if you're on Mac or Linux, and then if you're on Windows, you get it from here. Okay, this is going to be a fairly I should put in objectives. Those would be nice. Objectives. At the end this lesson will be able to install Docker on your computer. I mean, that's pretty much it. Okay. All right, so I have that set up. So here we go. We'll start with Docker's homepage for this. And we'll be good to go. So, right, I'm already recording a video. So now it's really just, how do I want to notify myself that this is like the point where something starts? I don't have like a bell. That would be really cool if I have like a high pitched thing. I know that Dan Schiffman, does he still do that on Coding Train? The bell. I know that like for the longest time he did that both for fun, but also because it made it easy to find where edit points were. And I do not have a bell. So, and I don't want to scratch the microphone because even though that works, that will not be fun for all of you. So I guess I'll just have to find it, and we'll go from there. Or I download and open installing Docker. Elgato has a bell sound. Does Elgato have I don't have a button for that. Oh, but I could have a Stream Deck button. Hold on. Maybe I can do that. Stream Deck. Oftentimes when I attempt to like add something in, it like just things don't work. Okay, soundboard. Play audio. Title, bell. Oh, is Elgato Stream Deck? Oh, it is. It has the same logo. I just see Stream Deck. I don't see Elgato Stream Deck, so that makes sense. All right. I need to rename you to be Bell. Oh, it needs a file. Oh, I have to go to the marketplace. What is wrong with you? Mouse first, mobile later. Experience the best of marketplace from your computer, not your mobile device, when I'm literally on my computer. It puts that up because I had the window too small. Oh, that's fun. Okay, do we have like a bell? Or a ding? No ding. How about bell? Sound effects. Let's see, we have bell ding resonate. That's pretty short. All right, I'm gonna try playing this, but I have no idea how loud this is gonna be, and I can't make this smaller. Oh, wait, now I can, kind of. All right, so I hope this is not too loud for everybody. We're gonna try it right now. That wasn't, oh, that was really quiet. I could hear it fine, but desktop audio, I think it was, I have to make that louder. Hold on, let me try it again. Oh, that was way too loud. Okay, I think that's about the same sound as my voice right now. So sorry about blasting your ears out for a second. Now let's see, how do I add that in? Oh, I have to log in to check out. Okay, that's Huh, do I even have an account? I don't know if I have an account with Elgato. I don't have an account. Okay. Well, I I won't be able to do that right now because that will just take too long to set up. So that's out. I'll just have to find it. It'll be fine. Okay. I'm gonna have to I'll have to re-watch these. I'll label them properly. So that'll be good enough for this. I can also see like the timestamp for this, so maybe I can write those down too. That could be smart. Need something for that. Okay. Either way, let's do this. So, number 1. All right. Oh, I know. I can use Canva. To continue another way. Can I just log in with email, please? Oh, that you sent to my, okay, you sent that to my email. Okay. Canva is pretty cool. I've been playing around with it to make some fun stuff. Let me see. Can I create new design? I want to create a sure, YouTube thumbnail would be good for this. Thumbnail? Possibly. And then can I just have this full screen? Now, can I have this blocked out? Nope, do not. Can I move to a new window altogether? Yes. All right, so I want to put in something like we have Docker. Where's my uploads? Aren't there supposed to be? Oh, there, uploads. Oh, and I can go back to. So we have Docker. And then yeah, some kind of title, Docker tutorial. So like, introduction to Docker. Something like that. And then we'll have down here another one, which is maybe a subtitle, which can be our installing Docker. There's like the bottom thing for this right there. I wish I could like tell it to go halfway through. That'll be fine. Okay, I think this works as a title. Can I make you full screen? Yeah, I could do that. And then we'll switch over to you. Oh, and you're like that. Okay, cool. So I think this will work. All right, so let's go ahead and get started with this. And oh, right, the other thing that I like to do is turn off where's the Twitch alerts. We're gonna turn off Twitch alerts, and then that should make it so that way I'm no longer getting audio from any alerts that come in. And we're gonna turn on Nightbot, the timer that I'm recording video. Okay, so I think now I'm ready to go. All right, let us do this. All right, so we'll start off, and then that was the wrong window. I guess I need my mouse over here when I do this. All right. Welcome to the Introduction to Docker course. In this first lesson, we're going to be going over installing Docker, well, on your computer. And there's a couple ways for us to do this. First off, if you have a Windows or a Mac system, we're going to have to go with Docker Desktop. And to find that, we can go to Get Started. And it should auto detect what operating system we're on and then offer up the download for that specific operating system. So for example, I'm on one of the fancy new Apple computers with the Apple chips. And so it wants me to download that, which is, well, correct for me. But if you have a different system, they do have the other downloads for you here available. So for example, the Mac Intel chip or a Windows computer. Now, if you're on Linux, you can download Docker Desktop here, but it's not necessary because it is also possible for you to go to docs.docker.com and find the, let's see, manuals, Docker engine, install, and then choose your flavor of Linux and then follow the instructions here. And this way you're able to install the Docker engine itself. Now, the difference between Docker engine and then Docker Desktop is that with engine, you just get Docker, and it's also going to be the native Docker. Now, I believe that Docker Desktop is going to be the native Docker on Linux too, but you also have, well, the entire sort of desktop application. And you may want that, but I found that I rarely use it, especially on Linux systems. So if you are on a Linux system, this is definitely an option for you to check out. Plus, this is how to get it installed on the other operating systems as well, not just Ubuntu. Now, once we have it installed, then we're going to come over to our terminal here, and just to make sure that it is running, we're going to run Docker images. And we should get this output here to show us, okay, repository tag, image ID, created, and size. And in this case, that's, well, we don't have any Docker images yet. We're just getting started. And that's what we've got here. If you have Docker Desktop, for example, on a Mac, I have this little Docker icon. There's a little leaf in front of it to sort of hide it a little bit. But you should, on your Windows system, it will be down the hidden little start menu thing. You should find it somewhere down there. In the case that it's not running, you'll have to go and launch Docker Desktop. And then in Linux systems, you'll have to make the installer should handle it starting automatically, but you could also just run the Docker engine manually too from there. And then that's it. Now Docker's installed and we're ready to go with the rest of the course. Thank you for watching. Bye. All right. I don't know how long I need to hold the bye for, but I think we're good there. So next up. Is to, oh, you know what? I could put in the relative time zone too, timestamp. That was around 46:31 that we finished. So let's like put it up, say like 42 or so. I don't think that was very, I'll do 46 at the end. Do you have intro and outro part plans? No, I don't. I don't have intro and outro part plans. Yeah, I know that I could set up that kind of stuff. I am not very good at like planning those type of things out. I need to figure out like what that would be. Sometimes I wonder if I should get a second Stream Deck and then attach, because I can't have the same Stream Deck attached to 2 different computers. Because that would be cool if I could say, okay, Stream Deck for Windows does that thing. Oh, we could put something in OBS. That would be interesting. But because it's a separate computer, that's its own thing. I might just cut off the title screen anyways, and then just use that same thumbnail in there. I'm not sure exactly what I would put that for. But okay, this was like what, 46, 0, I think. We can do that. Okay. Next up, running your first container. Just want to do our iSpell. The -m I think is what we normally have anyways, so I just want the -x, and this is now going to be okay. Great. So Docker Ubuntu, so that's fine. What's the one for accept this word this time only? Oh, and A is for the rest of this session. Okay, got it. So. Interesting. It was kind of surprising it's not suggesting that this be like VIM capitalized like that. I wish I could change this. I don't think I can. Okay, I think that's fine though. All right, running your first Docker container. So. All right, by the end of this lesson, you will be able to what do we do here? Let's add in content. Great, we have Docker set up and running in our system. Let's go ahead and use it to run an Ubuntu container on our computer. It doesn't matter what computer we're running, we can run Ubuntu on it. Perfect, so run an Ubuntu, or create an, okay. Create run docker run -it ubuntu command to get started. Okay, now we verified all of this by copying them directly in from the terminals. We know that this works. I'm mostly looking at formatting stuff here. After pulling down the Ubuntu image, we're dropped into an Ubuntu interactive shell. Ubuntu is a popular Linux distro, and that goes to Wikipedia Linux distribution, so what that is. And we are now running it inside of our own system, regardless of what operating system we're currently using. If you're familiar with Linux, you can poke around using commands like ls and cd. Please note that this is a bare bones version of Ubuntu. Many commands are not included, like vim or even nano. So I believe vim is technically capitalized like that, and nano is capitalized like that if I'm not going to wrap it in the single quotes, or whatever those quotes are, the backticks. When you're finished poking around, you can exit the container with the command exit. This will drop you back into your normal shell on your system. Okay, so now I have that. We run u and then exit. Good. Congratulations, you have now run your first Docker container on your computer. So yeah, that's pretty much it. We're gonna create a Docker container running Ubuntu. Oh, and I want to create a Docker container. Okay, so we can start here for that. For you, we want to duplicate you, and now you're going to be, what are you? You are creating run your first okay, and then over here we have just you. I'll reset. All right, we are ready to go. So number 2. Come on, go away. Go away. I guess, oh, no, there it goes. My mouse finally disappeared. All right. All right, since we now have Docker installed, let's go ahead and run our first Docker container on our system. And in this case, now I'm on a Mac, which is running obviously Apple hardware. Let's go ahead and run an Ubuntu operating system on our computer using Docker. And we can do this really easily and fairly quickly. We're going to use the command docker run -it. This stands for interactive and terminal. Basically, it's going to allow us to connect to the terminal, connect our terminal to this container. And just do Ubuntu, and that's it. This is the command we're going to run. Now, when I hit return, it's going to tell us, okay, we don't know what, we don't have Ubuntu locally, so we're going to have to download it. It's going to download it from a repository. This is very similar to like GitHub, but for entire Docker images. And you'll notice that our shell has changed. We're now in this root 4E95 that sort of like looks like a hash of some kind. That's kind of exactly what it is. We're now inside of Ubuntu. If I were to try to use one of the commands that I normally have access to, like I have an alias LL for an ls-al, Oh, I guess this works because it's in Ubuntu here. But this is not my home directory. This is not what I'm used to looking at. And in fact, if we see, yeah, there's a home here, Mac users, we have /users. My home directory, I'm currently logged in as root. I definitely was not logged in as root beforehand. So we are inside of an Ubuntu operating system, essentially. Now, we can play around with this using all the normal commands that we're used to with Linux, if you're familiar with that. But some commands won't be here. Like this is a very stripped down version to try to save some space. So if we were to look for like Vim or something, that's not here. So when we're done looking around and we want to exit out, we can just type exit and we're back into our shell again. And that's it. That is running our first container and having everything set up for us automatically by Docker. Anyways, hopefully this was helpful. Thank you very much, and I'll see you in the next lesson. Bye. All right. That's that. Have I thought about getting a prompter? So I've been hearing about this. I've actually seen like a lot of things about the prompters. Is that Ilon? Let me take a look at that. Like somebody was suggesting to like Scott Tlinsky to get a prompter. Where would I put it? But yeah, let me take a look at this. So it's Amazon.com. Also, we have a break coming up in 5 minutes. So I'll probably go up and see if maybe we can find Zilby in that time. Let's see. I am not logged in. That's good. Let's see. I want prompter 12-inch. Oh, so yeah, these things. Oh yeah, because the camera can go behind it. Now, right now I just have like a Logitech webcam. Would I have to also get one of these cams? That would be pretty cool though. What's the refresh rate on them? Could it like actually do programming stuff on it? Or is it only oh, that's cool. Like a little teleprompter that goes up there. Oh, I would lose like this. They do look, some of these look actually pretty cool. I would, oh, if I have another desk next to me. If I were to switch that to that desk and maybe like instead of my normal stream area, have it where like I have my laptop down, we're doing that, that could be interesting. I could just buy the glass on its own. And then just what, put this in front of my monitor? That would be cool too, but you might see it because it's too far away from the camera. Like isn't the entire way that this works is because there's like a dark box behind it? It needs to have no light back there. These could be really fun to do. I am gonna put it onto a list to try out. Yeah, I need the thing to be dark. Okay, that sort of makes sense, right? Because otherwise it would become a mirror and then the camera would be watching itself instead of me. All right, I'm gonna I'll leave that over here though. I'll probably have to take that off eventually. But yeah, that seems like it would be pretty cool. Oh, this thing behind me? The headrest for my chair? Yeah. Okay, so this one's done. Oh, I forgot to look at the timestamp of when we got it done. So this was before, significantly before. Actually, now it's 010139. Okay. List Docker images. Oh, and the ads are going to start in 30 seconds. So what I'll probably do is go take a break, get another drink, because this one's done. We can try to find Zilby too, but he won't be on the screen for very much during, well, the recordings, essentially. Ooh, okay, so you don't want that. Okay, so that's 3. Oh, and that's good. Okay. Shandan, hello. How are you doing today? You're not understanding CORM? Which part about it don't you understand? I know it's pretty complicated. There's a lot of interesting things. An ad break just started on Twitch for 3 minutes. Shandan, if you ask your question, I'm gonna go grab a drink really quickly. I'll be right back, but I'll answer it as soon as I get back. If you have it down. So I will see you very shortly. Zilby was sleeping, so I didn't want to bother him. 40 seconds left in the ads. All right. Okay, so we have you up. I don't know how this is going to look like on the website. I might want to fix this. So if I do something like 1, 2, 3, 4, 5, let's make it like 5 each. One, 2, 3, 4, 5. Okay, and then we have Ubuntu, so that's the repository. We have our latest tag, image ID, created, size. Okay. That might be too close. There, that's a little better. All right. List Docker images. When we ran the docker run command, Docker automatically pulled down the Docker image Ubuntu latest for us. We can view the images that are on our system with the command docker images. So then we do docker image. Objectives. Okay, so we have our images. And we just did this one, but now it's going to be not 3 weeks ago anymore on the video. Yeah, I guess it depends upon when it was created. Let's go through the table that Docker displays for us. Repository. I wonder if I do want this to be content. Like, I go back and forth on that. Repository. Docker stores its images in repositories similar to how GitHub stores code, projects, and repositories. Each image gets its own repo, which makes it easy to know which image we're creating a container from. When we ran the command docker run -it ubuntu, the Ubuntu is the name of the repository. Something to note, single name repositories like Ubuntu are official repositories. So I want you to determine if a Docker repo is official or not. Something to note, single name repositories like Ubuntu are official repositories, as in they are created by Docker or an official organization. For example, the Ubuntu repo is managed by Docker, so you can be assured that it is what they claim it to be. If the repo had a namespace like brookzerker/Ubuntu, then you would know that this wasn't the official Docker version of Ubuntu, but rather one created by the user brookzerker, which, happens to be me. Tag. The Ubuntu image, and these should be one level more. The Ubuntu image has a tag latest, which denotes that it's the latest version of the Docker image available to us. Note that the tags can and often do correlate to the version of the software that they are wrapping, but they can be independent as well. If we wanted to install an older version of Ubuntu, we could have specified the tag when running the container with the command docker run-it ubuntu 20.04, which would download and run Ubuntu version 20.4, 20.04, instead of the latest version available. This can be very useful because we often want to develop on the same systems that we are deploying on, and the tags let us control this. Image ID. So then something about the tags. So choose which version to download with a tag. Image ID. Every image gets a hash as the ID, and we can use that instead of the name when running Docker commands. For now, we only need to be aware that the ID exists and where to find it. Created. This column shows how long ago the specific image plus tag was created. This can be helpful in debugging our code in case it stops working with newer versions. Size. Docker is a great tool since it allows us to run entire operating systems and other tools locally without installing them on our host systems. But the cost is how much space they can take up on our system. This specific image is taking up 69.3 megabytes of space, which doesn't seem like a lot, but some systems can take up more than 1 gigabyte. If we run into space issues in our systems, I'm using that a lot. How about computers? Take a look at the images. Take a look at the images can clean. Take a look at which at the images we have installed and see if we can clean them up to free some space. Okay, I like that more. All right. So with that being saved, I can move you off to the side. This is, oh, I forgot to update you. All right, list Docker images. All right, next up, listing Docker images. And this, we're starting, well, whatever. I'll do it near the end for each one. That'll be fine. There we go. Now the mouse is gone. All right, now that we have run our first Docker container, let's go ahead and take a look at the image that we used. We can do this with the command docker images. Now, we did this initially when we first installed Docker, and we had no images whatsoever to look at. But now we have one image. It's this Ubuntu image. And we can see we have some information here. Now, before we had these titles, but with no images to look at, but now we have some context for it. So we can dive a little bit deeper in and see what we have. Now, first off, repository. Well, this is sort of like the GitHub repository that I mentioned before, which is the Ubuntu repository. And now that just happens to correspond with the project Ubuntu, the Linux operating system, and you are going to see this a lot. This is a very big pattern within the Docker ecosystem, that you name the repository after the technology that you're getting in the Docker container. Tag. Now, right now we have this tag latest. And you notice we didn't do anything to cause the tag latest to show up. It just is there. And that is to let us know that by default, we get the latest tag. However, it is possible for us to set the tag specifically. Now, we could do that if I want to use our run command again. We can do docker run -it Ubuntu, and then colon to give it what the tag is going to be. And we want, let's say we want 20.04, which is going to be a very specific version of Ubuntu. Please note that the tags are set independently of what the actual content is. Now, hopefully, whoever's running this repository is going to set the tag 20.04 to correspond with the version 20.04 Ubuntu. That kind of just makes sense to us. And for the most part, especially with the official repositories like Ubuntu here, and I'll get into that in a second, that's exactly what we're going to run into. But with other, repos, it might be a good idea to look into it, and we'll show how to find more information about these repositories in future videos. For right now, this is how we can set the tag. And so if I run this, it'll tell us that we don't actually have this tag, and it's going to pull it down. And there we go. We're now dropped into another version of Ubuntu. I'm just going to go ahead and straight up exit. And let's do our Docker images command again. And okay, so we have next up, image ID. So the image ID is the hash of the image itself that we want to use. We can actually use this ID in lieu of any other command. So if you know what the ID is, you can then do docker run with that command, as opposed to using the nice name here. Created at. So the created here is interesting because this is not when we downloaded and got the image onto our system. This created is telling us when the image was created and uploaded to Docker itself. And so it's telling us, okay, so the latest version was 12 days ago. Okay, that's a little bit under a week, but the 20.04 tag, that was 2 weeks ago. Now, because the tags are not, they can be updated and they can be changed, and the contents of them can be changed. It is possible for something like 20.04, which is, that should be set, right? There shouldn't be that big of updates happening to it, but it's possible for somebody to upload a new version with the tag 20.04, that exact same tag name combination. And if that happens and it breaks whatever code that you have that's running inside this container, it can be helpful to know, oh, they updated the image, that's why it's breaking now. Just something to be aware of, that it can happen. And then when if weird stuff happens, then that's something to be aware of. And then finally we have size. So our Ubuntu latest is taking 69.2 megabytes up, and the 20.04 is taking 65.7 megabytes up. These are then two different things that are each taking up over 60 megabytes of space in our system. Now, this doesn't seem too much right now, and it's not. But I have seen Docker images take up of excess of 1 gigabyte in the past. So if we are running out of disk space on our computers, then it might be a good idea to just run a Docker images command and just see if we're using anything up. In a future lesson, we'll go over how to delete images, which is one of the ways of, it is the way of cleaning up a lot of disk space really quickly. And that's it. This is how we can list all of our Docker images that we have on our system and available and ready for us to use. Thank you so much for watching, and I'll see you in the next video. Bye. All right, and then what is this? This is 0, 1, 1, 8. Okay, 3 down. What was that? I got a... Oh, there was the tweet from the Rust Foundation about the marketing specialist role, which it'd be interesting to work for the Rust Foundation, but I'm not that interested in it. I would feel that there's probably too much politics in there. All right. Find and pull Docker images. All right, so everything looks good there. Let's go ahead and jump in here. So far, we've run the official Ubuntu Docker image directly with the Docker run command. But this command will not only pull the image, but also run it. In some cases, we just want to pull an image and make it available on our system without running it at the same time. We can do this with the Docker pull command. I guess like download a Docker image without running it. To find an image to pull, we're going to visit Docker Hub, which is the repo that Docker maintains public Docker images. To use the repo, we can, so to use, let's just say like Docker Hub. To use Docker Hub, we can search for any operating system or software, and if there is an image for it, we can pull it. For example, I think this doesn't need to be a personal. We'll search for Postgres and find that there is an official image for the Postgres database. So also, let's see, find Docker images on Docker Hub. Let's see. Now, this probably works here. You would call Docker Hub a registry rather than a repo. Oh yeah, that's probably a good point. That is right. It is a registry, just like GitHub is the registry as opposed to an individual repository. Yeah, I like that. Let's see. Which is the registry that Docker maintains public Docker images. To use Docker, okay, so that's good. I do a lot of deployments to AWS and use their managed databases. As of the writing of this article, AWS supports Postgres 16.1, which happens to be the latest version of Postgres. However, I want to make sure that I'll be using this specific version in the case that Postgres updates, but AWS lags behind. So I'll switch to the tags tab in Docker Hub. Also, Skimmus, hello, how are you doing today? And find the tag representing this specific version. In this case, it's 16.1, which, you know, kind of makes sense. To pull this specific, okay, so find Docker images on Docker Hub, and then also find a specific tag for an image. On Docker Hub. To pull this specific image down, we'll use the docker pull command, docker pull Postgres 16.1. And then we have our output, and that's it. We now have an image for Postgres version 16.1 available on our computer, ready for when we need to use it. We can view it with the docker images command. Okay. I am really curious about how this is going to look in the in the webpage. Is today a recording session? It is. It's a verification, so like second pass through each article and recording it down. So yeah, absolutely. Okay, so we have that. These are our objectives. We've got you. We have no other things. Okay, so I think we're good to go. You over there. We want you. We also want you. Let's close you. Go to hub.docker. This will be good. Oh, that one, that side, this side should be good. This drops me straight into, oh, my homepage. That's not great. Let's go ahead and log me out. That's what I wanted to see. All right. So with that being said, oh, right, next up, update you. This is find and pull Docker images. And I think we're ready to go. So I'll go ahead and, oh, you know what? I've been having my thing on here where I just sort of stare blankly at the screen, but that's not really all that helpful. But I think I'm going to be cutting this out anyway. So I'm just using this as a thing to see in the video editor. So I'm going to have to do that because I have me in here. That's so fun. All right, well, whatever. Now I don't have to be silent in it now that I know that that's what's happening. Okay, so let's we're gonna find Docker images in Docker Hub, find a specific tag for an image on Docker Hub, and download a Docker image without running it. Got it. All right, let's do this. In this lesson, we're going to go on to Docker's registry for Docker images and search for a specific Docker image. Now, in this case, we're going to search for Postgres, but you can use this method to find any technology as long as somebody has created a Docker image for it to use. So, with that being said, let's jump into it. Here we are at Docker Hub. Now, Docker Hub is the registry for Docker images, or at least it's the one that is used by default by Docker. And it's also the one that most people mean when they say, Docker registry. It's the default one. And because it's run by Docker, we can generally trust it too. It's sort of like when somebody says, "Oh, are you going to throw that up online?" and they're talking about GitHub. That's generally that. Currently, it's the default, as of at least this recording. Now, I want to find a different image to show off using our Docker pull command, so we can pull images down without running them at the same time. And the first thing that I can think of is a database, because databases are incredibly useful to have, and it's a pain to install them and set up on their own on our computers, but they're really easy to when we're doing them inside of Docker. Now, my current favorite database right now is Postgres. So let's go ahead and find that. So I'm just going to type in Postgres here. And there are 10,000 results for Postgres that were found, but the very first one here is the one that we're going to want. Now, how do I know this? Well, previously we mentioned that if it's just a single name, then it's going to be that's going to be the official one, right? And that's exactly what this is. It's a single name, so we know that this is an official image. And we even have this little tag here, Docker official image. Now down here, Bitnami Postgres has a different icon on it. It's a verified publisher. So there's a subtle difference here, which is Bitnami is not associated with Docker, the organization at all, but they're verified. So this is sort of like that check mark next to the name to say, okay, well, Docker is verified that this is from Bitnami. Like we can trust that this is from Bitnami, and if you need something from the company Bitnami, this is the one to go from. But if you want just Postgres, this is the one we want to go with. And I really like the Docker official images because I am as confident as you can be with third-party anything, to download and run on your system. Now, if we were to go far enough in, we'll stop seeing these blue check marks. Let me go down to the bottom here. Here, sponsored open source. Let's go like 10 pages deep. And at this point in time, we now have just anybody uploading them. So for example, Cycloid Postgres dump has created this image for image to be used, and they don't have any kind of icon next to them. And so we know that this is not from Docker. We know it's not from Postgres or any other like known individual or organization, because it is a username / then name of the image. And this is a very common pattern that you'll see in Docker, which is everything is namespaced. Only official Docker images are allowed to have single word names. So let's go back to our first page here. In fact, I'm just going to say I want official Docker images only. There's only one for Postgres. So we're just going to click into here, and we have our page where we can now see how we can get and run Postgres. And there's a lot of good information on here. Now, I do use Postgres a lot, and one of the places that I run it is in production, and I do like to run it on Amazon. I have a managed database in Amazon that's a Postgres database, and as of right now, I believe that 16.1, I think, is the most recent version of Postgres on AWS. And I want to make sure to lock it to that version here for development that I have on my system, so that way I can be confident that whatever features I'm using in Postgres for development is going to be the same. They're going to be supported on AWS where I'm in production. So we're going to go to tags here and see our list of tags. And there's a lot of them. If I were to just attempt to scroll through these, it would be really, really painful. And we can even see it starts up here with 12, which is pretty old. I'm not really fully sure the ordering of these, how Docker decides to order them. Generally takes doesn't make too much sense to me. So if we scroll all the way to the bottom of this page, we can see there's over 10 pages of this. So that's not really helpful. I'm going to go back up to the top. Let's scroll all the way up, and I'm going to search for 16.1. And we have a couple choices here. So we have like 16.1 Bullseye. I don't necessarily know what Bullseye means, so I'm going to avoid it right now. Bookworm. Okay, here it is. Tags 16.1. This is what I want. And then if I click on you, it will then show us, okay, so what architectures it's available for, what it's all built on. None of this really matters that much. What's really important for us is to see that this is still part of that Docker official image, but it's hopefully locked to Postgres 16.1. Now, it's good to point out that anybody on the Docker team can upload with any tag and just continuously overwrite it. So it's important to remember that the 16.1, it should correspond with 16.1 Postgres, but it's possible that it doesn't. Now, with the official repositories like Postgres, you're not going to run into that problem. It's going to be a one-to-one connection, a one-to-one something. It's going to be one-to-one of like the version of Postgres to the version of, well, Postgres inside the Docker image. If you're running off of a non-official image, one of those that just is username / Postgres, let's say, they could say that is like latest, but it's Postgres version 8, for example. So something to be aware of. Even though, I mean, it's not really a problem. It's just, please be aware of that. All right. So now we have our name, our repo name, and we have the tag combination that we want. Let's go ahead and download this into our system without running it at the same time. So Postgres 16.1. I'm just going to go ahead and copy this. We're going to switch back to our terminal, and we're going to run docker pull. So pull is going to pull down the image. This is sort of like git clone. And Postgres 16.1. And that's it. I don't need anything else. We hit return. It's going to say that it doesn't have this locally, and it's going to go ahead and pull from Docker Hub. And now that it's here, we can now see Docker. Well, we can see the Postgres image that we just pulled with Docker images. And here it is. We have Postgres 16.1. It was created 4 weeks ago, and it is 448 megabytes. And that's it. We now have a Postgres image waiting for us to create a container from it on our system. Which is pretty exciting. Anyways, that's it for this lesson. Thank you so much for watching, and have a great rest of your day. Bye. All right. I keep on forgetting. I want to record the timestamps that I'm doing these on. So do that. This is 01, 39. Like 59. All right, good to go. Google, what does Bullseye mean in Docker tag? Images tagged with Bullseye, Bookworm, Stretch, Buster, or Jesse are code names for different Debian releases. At the time of this writing, the stable Debian release is 12, and its code name is Bookworm. Bullseye is Debian 11, Buster is 10. Okay. For some reason my brain was going into like 10 dot June 20th. What? Okay, and then June 20th, 2023. Okay. Well, Alpine goes to Alpine is then Alpine, right? All right. Cool. That's good to know. We learn something new every day, which is awesome. Thank you for that, Hugh. Alpine is a really small image, pluses and minuses there. Yes, absolutely true. At the end of the course, we do use, let's see, where is it? After the deving with Docker section, we down here in miscellaneous, we have using Alpine to reduce Docker sizes. So we do go over using Alpine. Let's see. Include Dior. Hello. How are you doing today? Is there a networking section yet? So yeah, I have network. Where do I put networking? I do connect two containers with a network here. So I do have them in the deving with Docker section. Then Real Enrico, hello. How are you doing today? Where's your previous courses? Did you finish the new? Oh, so I canceled the Axum course because it was updating too much. So because Hyper updated to 1.0, and in the course of Hyper updating to 1.0, they took out a lot of stuff that Axum was relying on. Everything changed, and like Axum has now done 2 breaking change updates since then, and they're not at 1.0 yet. So I'm kind of waiting until they get to 1.0, at which point then we're going to create a course for it. But I want them to settle down a little bit more. Because I was getting like, I was like, oh, I did not look forward to like, okay, let me write, oh, I have to rewrite this, I have to redo this, I have to redo this. Yeah, that was gonna suck. I honestly don't know. Like I think it could literally be any day that Axum 1.0 ships. I believe that the only reason it hasn't is because there's other libraries that they're relying on that need to update to the latest version of Hyper, and then or support whatever that latest version of Hyper is, and then they can go. So I think that Axum is like kind of ready, but some of their dependencies are not. And those are not controlled by the Tokyo environment, because otherwise I think all the Tokyo stuff, they're just sort of like waiting now. Have you read any of the tech stuff on Docker that is written up at pythonspeed.com? Might be useful pointers if you want to incorporate. I have not. So yeah, that would be something interesting. Let me add that to my list to take a look at. I do sometimes try not to like read other people's courses too much, because I don't want to like accidentally steal what they're doing. Like if I'm going to recreate what they do, I want it to be like just from my own brain, as opposed to like, oh, I was influenced by them subconsciously and now I just recreated everything they have and think that it's me. That would suck. So let me check out. That being said, like I'd be happy to like sort of check out what they are, and after I create the course, I usually read up on some of these things. So what is this? Pythonspeed.com. Pythonspeed.com. Okay, and that's it. That's all that stuff. Let's continue on. Oh, delete the Docker image. Which one are we deleting? Oh, I think we delete the Ubuntu one. Oh, it's like all of the Shawsums. Oh, that's fun. It's like, this is all misspelled. How could you possibly live with this? Okay, there we go. All right, delete a Docker image. Obviously, delete a Docker image. Delete a Docker image. Docker images can take up a lot of space, and sometimes we need to clean them up. Docker gives us an easy way to remove images from our system. We recently installed the Postgres image, which we can see is taking up 447 megabytes of space. All right, so that's the one we're doing. We can remove this image and free up that space with the docker RMI command. It turns out that Postgres had a lot of layers, that is, small images that built upon the base image, in this case, the Ubuntu image. When we deleted the image, all of the unused images also got deleted for us. All of the unused image layers also got deleted for us. Okay, so just a really simple one, just using docker RMI. So, all right. Good to know. So let's you haven't heard the whole Docker course? Did I explain layers somewhere? I don't remember. I don't think I really officially go through layers. I was thinking this is sort of like an introduction type thing. Do you think that it's like essential to go into like what a layer is and how that works? Like how the actual Docker images work? Like I've never run into an issue where like needing to know the layer system stopped me from like using Docker. It's a bit unclear who you're pitching this to. Okay, yeah. So this is an introduction. So yeah, as here, I want to do this as an introduction to Docker. So like you're getting going with Docker. Like at one point you were saying what Ubuntu is. Yeah, I have noticed that like a lot of I guess this is like my teaching background coming in. I've taught a lot of people. They're like, oh yeah, they know this type of development type stuff, and you're like, wait, well, what's Linux? It's like, wait, you don't know? Okay, fine. So I tend to not assume those things because it's kind of funny how like that works sometimes. Like, if you go through all of your school and you're only on Windows systems, like you could be aware of Linux and like know that exists, but not know like specifically like Ubuntu, or maybe you've heard of it, but you don't really know what it is. Things like that can happen quite often. So that's usually why I go through that kind of stuff. And I try not to take too much time with it, so I don't piss off everybody else who does know what it is. Okay, so delete Docker image. We have nothing here. That's fine. All right. Okay, so let's go over this. Deleting a Docker image. Let's take a look at the images that we have here. So we have Docker images, and let's go over how to delete a Docker image. Now we just in the last lesson we installed the Postgres 16.1, but we have no use for that right now. And then also we have this Ubuntu 20.04 that we had, that we downloaded as part of the tag example. Let's go ahead and delete both of those images from our system because they're taking up 448 megabytes and 65.7 megabytes respectively. And we can do that with the docker rmi command. So if we do docker rmi Postgres, now if I try this, it should, it doesn't know what this is because it assumes that if I don't put a tag on it, then I'm going for latest, and it can't find that. So I have to put on the tag. So in this case, it's 16.1. And we can see that it deletes both the image, so it untags it. So that means that this image is still in our system, but then it also immediately deletes the image. But there's a whole bunch of these things here. Well, it turns out that Docker images are actually just a bunch of other images layered on top of each other, which makes it easy to build new ones, but this is also one of the reasons why it takes up so much space. It's also why it's so fast to get up and running. We don't need to know too much about how the images work, just to know that that's why we always see so many of these things whenever we do something with an image. Let's go ahead and also remove this Ubuntu 20.04, but this time I'm going to use the image ID for it, which we mentioned earlier that you can use to do any of the commands with. I'm just going to show this off here. So we do docker rmi, give it that image ID, and it it's being used. All right. We'll have to stop that first. So we'll have to do docker. I actually don't want to do this anymore. Okay, I'm going to restart the recording. And by restart the recording, I mean, we're just going to do it over again. Let's go ahead and docker pull again. This is our first take 2 of the day. We'll just only do this one. All right, so I can start off with that there. And we can take 2. We'll see how this goes. Let's talk about how to remove a Docker image from our system. Now, we mentioned previously that these Docker images can take up quite a bit of space. For example, the Postgres image that we just downloaded is taking up 448 megabytes of space, which is, I mean, it's not a huge amount, but it's not a small amount either. It's almost half a gig. And we don't need that right away, so let's go ahead and clean it up. Since we don't need it right now, let's just delete it. We can do this with the docker rmi command. So remove images, that's what it's short for. So we're gonna do docker rmi Postgres, and then we have to be very specific about this. I can't just say docker rmi Postgres because by default, it's going to look for the latest tag. And we can see here that we don't have a Postgres latest, sort of like we have the Ubuntu latest. We only have Postgres tag 16.1. So we're going to have to reference that with a colon 16.1. This will now remove the Docker, the Postgres 16.1 image. And there we go. Okay, so it deletes it. It's pretty fast to delete it. And we notice that not only did it delete, the one thing here, it also deleted all these other things here. And it turns out that the way that Docker works and the reason why it's so fast is because Docker images are actually layers of other images. So whatever these images represent, other ones were built on top of it. So we might have something like Ubuntu, and then, you know, they added something to it, they patched it, whatever, and then eventually we installed Postgres on it and configured that up here. And that's it. So now we have successfully uninstalled and deleted an image from our system, and we've freed up almost 0.5 GB of space. Hopefully this was helpful. Thank you so much for watching, and I will see you in the next lesson. Bye. All right, that was better. Update a Docker image. Composition of Docker commands in Bash. Docker remove. Oh, yeah. So yeah, if you want to like remove all of the Docker images altogether, you can do that command where you can sort of like combine them together. And then if you want to, you know, Hugh, if you want to like put them together, you can replace that like second line where you have like the $ for the shell with an and then it will first remove all the containers and then remove all the images all in one go, which is nice for cleaning up a lot of space all at once. All right, ad break, another 5 minutes. I'll probably continue moving through this because we took a break last time. You can also grep to select particular images or containers. Oh, absolutely, yeah, and you can pass that. Yeah, that's true. Shell scripting is so awesome. I think that people who know shell scripting and like know the power of it, they know. They're able to use that. People who never learn those skills, oftentimes I've noticed that they oftentimes jump straight into like programming itself and like use the shell only as like a launcher essentially. But like you can program in Bash, you can program in Zish or whatever other of your preferred shell is, and you can do some really cool things with it too. All right. Update a Docker image. Why do you not like... Is internet supposed to have a capitalization? Is that a thing? I always thought that internet was just a common word, not like must be capitalized. This reflects, okay, so when the internet first came into common use, most publications treated internet as a capitalized proper noun, but this has become less common. This reflects the tendency in English to capitalize new terms and move them to lowercase as they become familiar. So it basically is, in 2016, it was 54% of cases being capitalized. Okay, capital internet being preferred in the United States and lowercase internet being preferred in the United Kingdom. That's funny. Oh, and Hugh, I noticed that you found the same thing. The word internet can be both a proper noun and a regular one. So you often find it with both a capital I and a lowercase I. When referring to the www as a whole, it's a proper name and it should be capitalized. When it's used as a regular noun, okay, so am I using how am I using this? Service without an internet connection. I'm using it as a... Am I using it in a proper way? I don't think so. I think this is proper to use lowercase here. Right? Or maybe it just shows that I don't know how to use proper nouns. Use network. Oh, that's a good idea. I really wish that this had the ability to like change. But I don't think that iSpell has the ability for me to like just completely replace it with like my own word. That would be really cool. But I don't have that. So I'll have to remember to go in and find this specific word and then change it. So I'm just going to say, okay, accept you right now. Ooh, that's a good one. Okay, yeah. So no, I wanted to find internet without a network connection. All right. When we pull a Docker image to our system, it is locked to the version that was uploaded to Docker Hub. This is great as it allows us to use these services without a network connection. However, we also miss out on security updates that a specific tag may get. For example, the Ubuntu 20.04 image is tagged to the minor update 20.04. If a patch update for 20.04 is released, bringing the official version of Ubuntu to 20.04.6, then we'll be missing out on that update. We can fix this by running the docker pull command, again with the same image and tag combination. If there is a new version on Docker Hub, then it will download it and overwrite the version you have. We have locally. All right, so this is just update a Docker image. Since tags don't have to correspond to versions of the software they are representing, it is possible for an image to have a breaking change, even if the tag is for the same exact version. If you are running Docker in production and it suddenly stops working despite locking the image and tag, this could be the culprit. Run an update locally and see if you can reproduce the problem. This screwed me up so badly. Oh, and it passed. It really sucked. Oh, there is a shell escape. Oh, that's true. I could do shell escape sed internet network. Yeah, I could do that. We can try that next time. There isn't a way to revert back to previous versions of an image after you update them. They can provide security updates, but can also break your environment. You'll need to determine when the right time to update your images are. The general rule of thumb is to keep your local version of images up to date with whatever you have in production. Most cloud-based systems right now auto update and like pull again, and so you'll have to do something to lock that down if you want to. Which, I mean, there's good and bad things for that. Okay, so I think we're good to go. All right. For those of you who got ads, sorry, and welcome back. I guess we'll do an update for Ubuntu 20.04 in this specific case. All right, let's jump into this and do this one. Update a Docker image. Let's say we want to make sure that we have the latest version of whatever security updates an image could possibly have. Right now, whatever we have on our local system is, well, it's on our local system. Docker doesn't automatically go up and download new versions of a repo tag combination for us. So imagine we wait a couple weeks, half a year or so. If we still have this Ubuntu 20.04 on our system, then whenever we downloaded it, that's what it's set to be. This is one of the reasons why it's so important to see this created date here, as we can see that this was 2 weeks ago. So if they were to update that less than 2 weeks ago, maybe like, let's say they did one today or right now, then we don't have it. It's still up on Docker Hub and it's not on our system. Now this might mean that we're going to miss out security updates, right? Like what if they updated Ubuntu 20.04 with something that fixes a security vulnerability that we could then accidentally be running on our systems? That could be pretty bad. Now we can update this with a Docker pull command. So let's go ahead and run that right now. And we just run the Docker pull command again, just as if we're downloading it brand new. We just give it the exact same combination of repo tag that we had before. So Docker pull Ubuntu 20.04 in this case. Now, for right now, we just downloaded this, so there's not really anything new for it to download, so it's up to date. However, if it wasn't up to date, it would have downloaded whatever new layers it wanted to, and then, well, then we'd have the new version. Now, something to be aware of for this is because the repo tag doesn't have to be set to, it's not like a point in time. It can be updated continuously by whoever is maintaining that image. It does mean that breaking changes can be added in. A personal story here. I was working with a company and we had a version of PHP and an application set up on that, and they decided to update with the same tag. So it was the same version of PHP that was running on there, but they updated some stuff around PHP and some of the libraries got updated and our code stopped working on it. And it was the exact same repo tag version, but because our CI/CD system was downloading a new image every single time it ran, everything stopped working. And we had to update our code to work with the new version of, well, the Docker image. So something to be aware of. Now, it is impossible to roll back. Like once we do our Docker pull and we get the new version of Ubuntu 20.04, we're kind of done. That's the version we have now. And that's kind of what it is. So my recommendation, whatever you have in production, use that and update when production updates. And if production is always updating, then try to set your, and it suddenly breaks, update yours locally to see if you can reproduce the problem, because weird issues can, this is one of the sources of weird potential issues. Anyways, hopefully this is helpful. Hopefully it can, you can remember this in the future whenever something weird happens, and you can try it out, and maybe it will save you some time in debugging. And then of course, maybe not. Either way, thank you so much for watching, and I will see you in the next video. Bye. All right. Done with that. Mutable versus immutable tags. Some registries have settings that disallow tag mutation. AWS ECR definitely, no, not Docker Hub. AWS ECR, I mean, that's I didn't actually realize that about AWS ECR. I've used it for like 1 or 2 images total. But that makes sense. I do like the idea of immutable tags, but I also could see that, like, okay, we have like 20.04 dot, like, 29, and you have to like constantly update the images. I go back and forth with it. Or maybe you can have like ones that like you can have both, or maybe a setting. I don't know. All right, so we're on O2. List Docker. Okay, so list Docker containers. All right, so we should be good to go there. For testing an absolute fresh image, mutation is nice. Exactly. That's one of the reasons why I was like, okay, it is nice to have that, right? You can keep pushing to image latest, but then turn off mutation once it's stable or ready to ship to production. Yes, I can also see like having special tags, right? Like maybe what if like you could have latest is always mutable. What if you didn't have a tag system? Or what if the tag system wasn't the same thing? Like if you just push, it generates a random, or I guess a hash for that push. And then you can choose to tag it with like a release name. And so a lot of them just sort of sit there as untagged and named as you're deving them. You don't think that's possible in ECR? The mutation is a per repo setting. Okay. I mean, either way, whatever change would have to be a major update to how Docker works. I was thinking of like how to do it locally, right? Like I think it would have to be like a rewrite of Docker to really get this going, which obviously is not going to happen. Like maybe we'll see this in like other systems like Podman, but not in Docker. There's too much history to it now. Okay, so by the end of this lesson, you'll be able to list Docker containers. Now, how do we do this here? I wonder if I do, I do Docker PSA. So list Docker containers. So list running Docker containers. And then also list all Docker containers. Even Podman just conformed to the standard because they want to be adopted. If they become incompatible with Docker, nobody is going to use it, which is true. It's an unfortunate thing, isn't it, with our industry? I guess this is not just our industry, isn't it? It's like everything out there. If you want to be adopted, you have to conform to some standard that somebody else made, even if it makes no sense whatsoever. My favorite example of this is part of the JavaScript, like when that was being created. And Microsoft knew that they had to have something, they had to have JavaScript on their browser, but this is before it was open. This is before JavaScript was open source / standardized. And so Netscape / Sun Netscape owned it, with like Sun helping them out and like being part of that. And Microsoft reverse engineered JavaScript perfectly to make sure that it was like exactly the same, down to every bug. Like they found every bug, every problem with JavaScript, and they recreated it in JScript. Which I think is like the most, to me, that's just hilarious that like they reverse engineered, they figured out where all the problems were. And of course, because they had to be compatible with it, they couldn't actually fix anything. So they were forced to recreate all the problems. Which, talk about like using your engineering capabilities to do some interesting things. And Podman's kind of in the same position now, right? Like they just want to be an alternate that just does exactly the same thing. I was thinking about that with Git, right? Because we've been remaking the Git client in Rust. And there's some things about how like Git stores stuff behind the scenes, which is okay, but kind of sucks too. Like pack files suck, and like pack indexes. And it's like, okay, yeah, it's fast, but I bet there's significantly better ways of doing it now. And we like, if you have your API be able to recreate it on the fly, you can just store all that stuff in like a SQLite database or something like that, and it'll be significantly faster, or maybe not faster, but significantly easier to reason about and work with as a developer, and be backwards compatible. Podman did the root list by default before Docker, though, I think. So they push things. Yeah. Well, I mean, which is nice, right? Like Podman waited though until they were popular enough to do that though, right? I haven't used Podman, so I remember for a while it was like only usable on Linux systems. But I think now there's a client that works on Mac. Does it work on Windows yet? I haven't really paid attention to it. And I have it on my list for us to take a look at it. All right, let's go through this. Containers are the running instances of Docker images. Each time we use the docker run command, we are creating a container, and each container will hold its own state independent of other containers, even if they have been created by the same image. Let's show this in action by creating two containers from the same image. So we do docker run -it Ubuntu. I then cat hello world. I put in hello world. Cat hello.txt. Okay. Exit. I then run it again, and then no such file directory. Let's list out the containers that are on our system using the docker ps command. We'll have to use the A flag since the container shut down when we exited out of them. So there we go. See those? We have two different containers. One of them has the hello.txt file and one does not. Since they are both spun up from the same image, the only thing different about them is that file. And this file will remain on funny Ramanujan until we delete either the file or the container. Note that the containers have names automatically assigned to them. These names can be fun and interesting, but once we have many containers, they can be a pain to manage because they don't describe what the container is really for. We can set the name of the container when we run it with the -name option. So as we've seen, the -a option will show us all the containers, regardless of their status. By default, the docker ps command will only show the running containers. Right now, we don't have any, so no containers would display. Okay, excellent. Okay, it does work on Mac, has for at least a year. For Windows, they also had Podman Desktop in development the last time I checked. Okay, in development? Is it like working or is it still like in development? I don't feel like I would need to do a course in Podman, but like I could do a video on it, maybe. We can also do like something. As I mentioned, it is in my backlog to do something with Podman. Okay, so list Docker containers. And then I also have Docker containers up right now, right? So Docker ps-a. Yeah, so we have these two that we created previously. So that's something to be aware of. All right, let's do this. Here we go. We've created and we've deleted some Docker images, but let's now talk about Docker containers and specifically how we can list out which containers we have. Now, we've previously, in previous lessons, we've created two containers and we should be able to list them out, right? So if we do a docker ps command, now we don't see them. And that's because docker ps by default only shows us the running containers. And we don't have anything running right now. But we can tell docker ps to show us all of the containers, including the stopped ones. We can use the -a flag for that. So docker ps-a. And then here we go. These are those Docker Ubuntu containers that we created in the previous lessons. Notice that they have funny, interesting names attached to them. And by default, if we don't tell them what name to use, they're going to give us a random series of words that are interesting and then hopefully shouldn't have any collision. So there's another thing about these two, which is no, these ones are all their own images here, so we would expect that they're going to be different, right? But I want to show off how each container has its own state too. So I'm going to go ahead and we're going to create two more containers from Ubuntu latest. So that would be this one here. And we're going to put in a file in it, and we'll also just sort of set up their names too. So we'll do docker run. I want that -it. We want a -- name, and this sets what the name is going to be. So this is going to be Ubuntu with file, let's say, and I want this to be Ubuntu. Okay, so I'm now dropped into Ubuntu here. Let's go ahead and create a file in here. So I'm just gonna touch example file.txt. Let's cat into example file. I didn't really need to do the touch for that. And in this case, we're gonna say hello world. And if I cat example file now, we get that hello world out. Excellent. Now, if I exit out and we do a docker ps again with the -a command, we see here's our Ubuntu with file, and it is off of the Ubuntu image here. Now, this one is going to have that image in there. If I was able to restart the Ubuntu container and then connect into it, I would actually see that image, that file inside of the root directory. And if I connected to this one, the heuristic Shamir container, I would not see that file. So each container holds its own state, which is really nice. It allows us to use containers for an entire project, and you don't have to constantly delete them and recreate them. They hold whatever the state is until we decide to delete them. Now, that being said, I would be careful about what you store inside of a container. We generally want to make sure that our container, like we can delete our containers at a moment's notice and we don't really lose anything important. So something to be aware of is try to keep these containers free of anything important. And that is, I think that's all the objectives for this lesson. So we were able to list out all the containers, list out all of the containers, and then also set a container name when we create it. Thank you so much for watching, and I will see you in the next video. Bye. All right. All right, delete a Docker container is next. I did pretty good with the spelling this time. I remember the last one, it was absolutely terrible, like really terrible spelling throughout the entire course. So I'm happy about that so far. How did you get the hybrid line numbers working in Helix? I thought they supported absolute or relative, not hybrid. This is relative. How am I, oh, you're right. I forgot that I even had that feature. What did I do? Here's my config. Line number relative. How did I get that working? This is the config. So, okay. One of these must be it. Okay, line number display absolute simply shows each line's number, while relative shows the distance from the current line. When unfocused or in insert mode, relative will still show absolute line numbers. So all you have to do is put in relative. That's it. So yeah, that's how to do it. So apparently it's default for relative, which is actually really nice because I kind of like that. Yeah, so relative does what hybrid does in Vim. This is the kind of thing that I like about Helix, but probably because it's how I would want to set up Helix. If I didn't want to set up that way, it would probably drive me absolutely insane. All right, let's dive into this. When we quit out of a running Docker container, the container is stopped. This is the equivalent of closing the lid on a notebook computer. It goes to sleep, and if it were to be restarted, it would continue exactly where it was, where it left off. While this is useful for continuing to work where we left off, how about continuing to work? It can also clutter up our computer if we continue creating containers but never remove them. Let's begin by creating a Docker container and immediately stopping it. Okay, so I do Docker run it name, remove me Ubuntu. Okay, now we can run the container list command to see this container. Note that we are using the -a option since the container stopped when we exited it. Let's remove the container with the command docker rm container name or container ID. We can use the container name or the ID to remove the container. Since we named the container something easy to remember and type, we'll use that. The container now has been irrevocably removed. There is no way to recover the container or any data stored inside the container. Obviously an important note. All right, next up, deleting a Docker container. Recording time, or at least a place where I'm going to cut out the recording. Since I'm just recording this one thing and I'm going to cut them out of here, I don't really know what to call that anymore. All right, here we go. We've previously deleted a Docker image, but we now want to delete a Docker container. Let's go ahead and once again list out the containers that we have. We're going to do that with the docker ps-a command. And we can see that we have 3 containers here. I have that Ubuntu with file container, we have elated2 and heuristic Shamir, and they're all based upon Ubuntu or the Ubuntu 20.4 tag. Let's go ahead and just delete all of these containers because I don't need them around, and I can't delete an image until I potentially delete the containers. So we're going to go ahead and do a rm, a docker rm. Now the rm is for the container itself. The RMI, if we remember, is for deleting a Docker image, and we cannot delete an image unless there are no containers running from that image. So if for example, I wanted to delete the Ubuntu image, I can't until these 2 images are also deleted too. So let's go ahead and delete all 3 of these. So docker rm, and let's delete heuristic Shamir. So I'm going to copy that name, paste it in here. Now, sometimes it does take a little bit of time for this to delete, depending upon the size and the complexity of the container. This one's pretty simple, so it completes right away. And it gives me back the name of what it deleted. Okay, we can also delete based upon the ID, and I can delete both of them at the same time. So I can do docker rm, put in the ID here. I can even put in like this Ubuntu with file. It doesn't really matter. I can mix and match however I want. And there we go. Both of those are now deleted. If I do our docker ps-a command, we are cleaned up. We have no more containers. And we are good to go. So hopefully this has been helpful. Thank you so much for watching, and I'll see you in the next video. Bye. Your camera video gets a gray, grainy look sometimes when you bring your hands up in front. Oh. Oh, yeah. What is going on with that? Is it because it's trying to like auto balance like the white? Huh. I don't know what's going on with that. Yeah, it's some auto GS Volt. Hello. How are you doing today? It is some sort of automatic compensation, but I have no idea what's going on with that. I'm just using a Logitech. What type is it? It's like one of those super popular but also relatively cheap ones. I know that a lot of the big streamers have switched to like DSLRs and like really nice cameras on tripods to use. And I finally got mine back. I had lent it to my parents for years, but I don't have a good way to set it up. And okay, so main camera. I have a chroma key. I wonder if there's a chroma key. Audio, video filters. I don't know enough about this to like know what to do to fix that problem. Well, I wonder if it's an auto white balance. Can I like give it a white? I don't see like anything where I can say like, hey, here's like the white balance, just like hard code to that. So I have no idea. I'm not going to touch it because I'll probably break it. Do I have a light on the chroma key so that the color is even? A light on the chroma key? I don't see a light option on chroma key. You'd say, don't worry about it. Your content quality shines over any grainy. Yeah. Eventually, like someday, Oh, I mean, you mean like an actual light, like on the green screen behind me. I have two lights over there. So like here, if I turn on Zilby cam, cat cam, you can kind of see them. So like there's like the big light on the top left, and then the other light on the right. So I point them like away from me so they're not purely directly in my eyes, and then hopefully it feels like it's relatively even light back here, but like yeah, from a continuous improvement standpoint, sure, debug it further and spend time on it. Yeah, eventually I do want to like get better at that kind of stuff, but I don't know. It's not, as you sort of like mentioned it, the content I'm more focused on right now. And I'm also like, this is one of the reasons why I'm not charging like hundreds of dollars for the courses yet. Like there's this idea in business of like what got us here won't take us there, which I forget who initially said it, but it's hugely important. I really like that. So I'm still in the what got us there. Like I'm still in like the basic mod stuff. As I grow, I have to update my quality to like continue to grow, if that makes sense. But right now, you're all with me at the Before the Chasm, which is to me, it's a fun place to be at because we get to focus on the content more than the quality itself. Someday I'll probably hire like an audio video specialist to come in and just set up things for me. But I'll need money for that. Okay, let's see. That was delete. Run a Docker container in daemon mode. It's my secret password is apparently not correctly spelled. Huh. Yeah, that's okay for the rest of this file. Ooh. That lost its line. The problem with it, okay, so hold on. If I drop into you. Oh, oh, I can just shell escape like that. Okay, so hold on. So can I like helix this? Oh, I can. Okay, so what is this? This is run a Docker container. Where was that? Oh, that was here. The Postgres password, somewhere one of these things. Right here. Oh, I was hoping that would refresh this. Oh, it didn't. Okay. Uh-oh. GSFold, what happened? It was Marshall Goldsmith who said that quote. He wrote a book as its title. Okay. MarshallGoldsmith.com. Sorry about hitting you with that that URL, but that sound familiar. But yeah, I've never read the book, but one of my coworkers let me know about this, and it just makes so much sense. So I like that don't worry about it. I'm gonna add that into Nightbot. through spam protection options. I have so many links that I have to whitelist them one at a time. But we ran into a problem early on when I was streaming where people would come in and post links to really bad things. And so I had to turn it off, which really sucks. So I whitelist links over time. So that way, like now okay, so if you post that exact same thing again, it won't get caught anymore because Nightbot now knows that it's okay. And luckily it deletes the message, but like lets me see it. So I can still like see what the message was, but nobody else does. So I'm not gonna like anybody who is, potentially gonna click on it, they won't get hit by it. But yeah, the idea here is super, super important. And so many businesses get this wrong. It's kind of funny, actually. You don't self-promote, but links of universal value you do share from time to time. Totally understand. The self-promotion wouldn't be that, it's annoying, but not that big of a problem. The ones that go to not safe for life things, or definitely not safe for work things, or just straight up spams that are trying to get you to get a viewer to maybe lose money or something else. Those are much worse. Okay, so I was upset about this, but okay, we're gonna you okay, now I'm actually really curious. Did my change take? Or is it still going to be broken? Okay, so it's fixed. Was that the one it was fixed on? Or was there another one? Oh, that was it. Okay, so it did work. Okay. All right. Run a Docker container in daemon mode. Are those backticks supposed to be SU or SH? Which ones? Down here? Oh, these ones? Like SH? I think that they're SH for shell. SU is switch user, and this is me telling the markdown renderer how to colorize the contents of them. So shell. I guess I could also put in bash or ZSH too. It should work. Oh, I had SU on other ones? Uh-oh. Wait. Oh, yeah. Oops. Oh, why did I have... Okay. I always forget grep. Is it... Oh, wait. I have rip grep, right? I do have rip grep. Okay, so... rip grep is pattern path. Okay, so I want rip grep if three things SU from everything here. Was that it? Was that the only time I did? Okay, how about SH? Okay, that was the only time I've done that one. The problem with all SUs is I bet I have that's just gonna grab everything that has an SU in it. Which there's a tons of these. But the 3 ticks, I think that's fine. So all right. We're good to read through this now. Okay, run a Docker container in daemon mode. Until now, we've been running our containers in interactive mode, as in, as soon as they launch. Oh wait, I wanted my objectives thing. So probably like describe what daemon mode even is. Until now, we've been running our containers in interactive mode, as in, I don't think I need as in. As soon as they launch, we are dropped inside them to do whatever we want to do with them. However, we can run containers as a daemon, meaning that they will continue to run in the background without taking up the terminal. We've also been creating containers that don't have long-running tasks. That would be a good example of being a daemon. That's not true. Wait, what? We also have been creating containers that don't have long-running tasks. That would be a good example of being a daemon. What was I thinking? This sentence doesn't mean anything, and also it's wrong. I think I need to say so far we haven't I'm gonna have to rerun the spell check on this. Isn't like something like that? Now I don't know. Well, I'll run the spell check on it. Is this content you had authored earlier and now revising? Yes. So we went through and we wrote all of the articles first, and then went, okay, haven't. You know how like you're writing stuff down, and then just suddenly words don't make any sense, and like you've completely forgotten how to spell. And if that doesn't happen to you, then that happens to me. That happens to me all the time. It's the same thing where you say a word too many times, and now it just doesn't. It like feels wrong. It's like a weird. It's a weird quirk of the brain, and like that happens to me all the time. It's like I suddenly forgot how to spell haven't, because like I'm looking at this and it totally looks wrong, but no way that I'm trying to spell it looks right. So great. So far we haven't been creating Docker containers that that can run as a daemon in the background. Let's change this. For this example, we're going to create a container that serves a Postgres database in daemon mode. Try staring at your hand also has the same effect. What even is this thing? It makes me wonder, like, what part of the brain is like happening with that? I would have to imagine that somebody has studied that. Find the image. We kind of literally did this already, didn't we? Because when we did that, we went through and we found the Postgres image with the tag. So I don't think we need, oh, actually, you know what? But we also kind of do for the instructions for it. So yeah, okay. Find the image. The first steps whenever we're using a new image is to go onto Docker Hub and search for the image that we're interested in. In this case, Postgres. On the Docker Hub page for Postgres, they have an example command to get it up and running locally. Docker run name some Postgres, Postgres password equals my secret password -d Postgres. There are two new things we see in this command. -e Postgres password my secret password. This tells Docker to create an environment variable with the key Postgres password and the value my secret password inside the container while it runs. And then -d, this tells Docker to run the container in daemon mode. The -it options that we used before are not compatible with daemon mode. If we run this command, the image will download just like before, but instead of being dropped into the container, will be returned to our terminal and the container ID will be printed. We now have a Postgres container running in the background on our computer. We can see the status with the docker ps command. Note that we don't need the -a option since the container is active and running now. If we were to try to connect to the database with database management software, we wouldn't be able to connect since we haven't opened any ports between Docker and our host machine. The port that we see in the list command is the port that is opened inside the container. We'll learn how to open ports to our host machine in a different lesson, which I think is like coming up. Oh no, that's in the deving one. Okay. But okay, so there we go. All right, 5 minutes until an ad. Do you think I can get this done in 5 minutes? I might be able to. And then I want to start here. Fresh terminal. Oh, we do want you. Since we already did this before, I'm just going to go straight to here, and we're going to go down until we find how to run it. So that's what it's going to be. All right. Let's run a Docker container in daemon mode. You know what? I'm going to start here. All right, here we go. So far, all of the containers that we've created with our Docker run command have been in interactive mode, meaning that we've dropped into the container as we create them, and they take up our entire terminal. And as soon as we exit them, the container exits and stops. But sometimes we want to run a container in what's known as daemon mode, which means that it's going to run behind the scenes. It's not going to take up our terminal at all, and it will just sit there ready for us to work. It's sort of like a service, like any other part of our computer that just sort of is there and doing its own thing, and we don't have to take up an entire terminal window just to make sure that it's running. Let's go ahead and set up a Docker container ourselves in daemon mode. And the best container that I can think of, the best image that I can think of to use for this would be a database, a Postgres database. So let's go ahead and go back to the Postgres database Docker Hub page, and we're going to search for how to get this up and running. And down here, if we scroll down, we'll see instructions, how to start the Postgres image. So we can see, okay, so with Docker run, great. They give it a name with the --name, okay, some Postgres. There's this -e. Well, this is new. This is setting an environment variable to be available inside of the container. So it's going to set the environment variable Postgres password to the value my secret password. So we can change this to be whatever we want. And then we have this -d, and this is what tells Docker to put it into daemon mode. Now -it, which we were using before, is the interactive TTY, that's the connect the terminal to the container. We don't need that. In fact, it's not even compatible with daemon mode. We have to choose one or the other. And then finally, Postgres, well, the name of the image to choose. So I'm going to go ahead and just copy this. We're going to come back to here. We're going to now run you. And instead of dropping this inside, which, it's daemon mode, it's going to print out the hash, the ID of the container that it started. We'll go ahead and wait for it to download everything, well, the Postgres latest container for us. And there we go. Okay, and here it is. This is the ID of our container that is now running, and we can verify that it's running and see information about it with our docker ps command. And note that I don't have to use the docker ps-a because this is an actual up and running container. It is active. So there's our Docker container ID. Okay, so it's Postgres. This is the command that's running inside of the Docker container. We created it 15 seconds ago. Its status is it's up and running. Ports. Now, it's kind of sort of listening on port 5432. And I mean kind of sort of because the container inside is telling us that it is listening on port 5432. But we haven't mapped port 5432 from the container to our host system. So it's impossible for us to connect to it from our own computer. We just can't do that. Now, there is a way to do that, but we'll cover that in a future lesson. And then finally, we have the name, which is that some Postgres. And that's it. We now have a container that's running in daemon mode, and it's just running there. And we can now use our own shell for whatever we want to. And there it is. We're good to go. So that being said, thank you so much for watching. Hopefully this was helpful, and I'll see you in the next video. Bye. All right. How does Markdown files go from MD files to a book? You need some kind of processor render look for MD book that's one example. MD book is the Rust one, right? I do like the Rust Markdown book format. It's really good. I'm so much more eloquent than you. It's a lot of practice, Okay, ad break just started. It's been 2 breaks, so 2 hours since I took one. So I'm going to take a really quick break, go stretch a little bit, walk around, and I will be back in like 3 minutes or so. Pandoc is a good choice for converting Markdown to PDF. Oh yeah, there's a whole bunch of good Markdown tools out there. There's so many of them. Anyways, I will be right back. See you in a few minutes. All right, back just in time for the ads to be done. And we can, oh, I forgot to put the timestamp on here. Oh well. What was this? This is 3. I have no idea if these timestamps are even helpful to me whatsoever. Okay, next up, Docker for web, connecting to a running Docker container, which we'll be able to do with that running Postgres container, if I remember correctly. Ah, nice. Okay, connecting to a running Docker container. In the previous, objectives first. Interactively connect. Interactively connect to a running Docker container. In the previous lesson, we created a container that is running in the background. We can see that it's running with a docker ps command, but beyond that, there isn't much that we can do with the container. It is possible to connect to a container in interactive mode using the docker exec command, even if it's running in daemon mode. The only restriction is that the container must be running. This won't work on a stopped container. So then we see that, then we exec into it with bin bash, and then we go back in. We did a few things here. First, we listed out the running containers, so we can find the name of the container we wanted to connect to. Then we ran the exec command with the -it options. This allowed us to interactively attach our terminal to the container. The command in question was the bin bash shell. When we run the shell directly, it creates a new shell. Since we're in interactive mode, we are connected to that shell and can now run our commands or do whatever we want inside the container. When we are finished running commands, we exited out of the container. Since the container was started with the -d option for daemon mode, it continued to stay up even after exiting. Other commands. We can run, okay, so this is more that. We can run more than just the shell in a running container. Any command that can be run inside the container can be run as part of the docker exec command. For example, we could just run the ls command to list files and directories. Since this command exits immediately after running, there isn't a reason to use the -it options. So docker exec some postgres ls, look at that. In this case, we just ran the command in the container and the output was printed for us. Excellent. So that's pretty simple. So interactively connects to a running Docker container and then run a one-off command. So run a command in a running Docker container. I did colon as if I was going to do colon W. Nice presentation. Do you also create written documents using Canva Docs? No. I use a different document editor. What makes you stick with your current document editor? All of my other documents are there. Also, I didn't know that Canva had a document editor. That also, you know, is why. Okay, so we're going to connect into the Postgres one. Perfect. All right, connecting to a running Docker container and then also just run a one-off command. So here we go. We've created a Docker container in daemon mode and it just is running. Let's go ahead and take a look at that with the docker ps command. Okay, so we can see this here, but what if we want to connect into it? What if this was our code and we needed to see something inside of it or run a one-off command inside of it? How do we do that without like just restarting from scratch with that it command and have it take over the shell? Well, we can use the exec command to execute a command inside of the container. The caveat to this is that it must be a running container. We can't do this to a stopped container because a stopped container is the equivalent of, well, if we put our computer to sleep, you can't really connect into it at that point in time. You have to return it back on before you can do anything there. Same thing with containers. So we have this Postgres container and it's still up and running. What if we want to just interactively connect to it so we can just do whatever we want with it? Well, we can do that with docker exec. Now we do have to do that it command option again. So -it. And then we have to give it the name of this. So it's going to be some Postgres. And then we have to have the command that we want. Now, in this case, I want to get a shell inside of the container so I can just move around. And I happen to know that bash is available inside of this container. So we can just go into bin bash. And bam, we are now inside the container and we can now run ls, we can do whatever we want. And this is the running container. I can now debug it or whatever I need to do. And when I'm done, we'll just type exit. And just to show, when I exit out of this container, because it was running in daemon mode already, the exit didn't cause the container to exit out. It didn't stop it. It's still up and running. Now, what if I didn't want to get an interactive shell into it? What if I already knew the command that I wanted? It was just this one-off command. Do I have to get a shell inside, go in there, run the command, then exit out again? No, I don't need to do that. We just run the command directly. And then in that case, we don't need the -it anymore because we don't need to interactively connect our terminal anymore. Let's say we want to run this ls command and just list the files and the directories in the container where, wherever our directory is. So we're going to do docker exec some Postgres, and then whatever the command is. So ls. And there we go. We now have listed out from inside the container all of the files and directories. And if you could imagine if we had a shell script, if we had anything else that we wanted to do, we could now run that command in there and it would just do stuff for us and then automatically exit out. And again, our container is still running in the background. We didn't cause it to stop. It would only stop if it crashed and then stopped on its own. But none of the things that we did caused that. And that's it. That's how we can run our own commands inside of the Docker container. And that's it. Thank you very much for watching, and I will see you in the next video. Bye. Let's see. Runda Richai, hello. How are you doing today? What is Docker needed in general? Let's see. So GS Vault makes it easy to not run servers on your system. Think like Postgres for dev projects. It is really useful. Yes. It's also really useful for ensuring the correct versions of things. So let's imagine that you have a project you want to run, and to me, it's like even more important if this is on a team environment. So let's say you have a team of like 5 devs, and some of the devs have Windows systems, some of them have Linux, some of them have Macs. And you want to have a consistent environment that matches whatever you have in production. So let's imagine that in production, you're running on Postgres 14. Let's say you're using Node.js on the back end, and you have like Node.js, I don't know, like 18 or so, which is, I think that's that's no longer LTS anymore. That's an older version. But if you don't do anything, some of your developers might have like 22, like Node.js 22 and Postgres 16. Some of them might have Node.js 10 for some reason. Some of them might have like Postgres, like, 12 or whatever. Like all the versions are going to be different, and when they develop, there's different features that are available for them, or maybe it just doesn't work for them if they have like the Node.js 10. So in Docker, you can say, okay, here's like, you have to have Docker Postgres version 16. Like, and you can script this. Like, this is where you can say, okay, you run this script and it sets up everything for you. And the other thing is, you can have multiple versions. What if you have 2 projects, one that requires Postgres version 16 and one that requires Postgres version 14? You can have both of them up and running at the exact same time, and it won't cause issues. It won't cause conflicts. I really like Docker for that specific use case. So to me, Docker for development is way more impressive, attractive, than any other use case of Docker. Does that answer your question? All right. Stop a running Docker container. By the end of this lesson, you will be able to stop a running Docker container. Content. We've been playing around with the Postgres container for a couple of lessons now, but we're finished with it. That being said, a running container is taking up memory, RAM, and CPU resources on the system. If we have a very powerful computer, this probably wouldn't affect us until we have a lot of containers all running at the same time. However, it can be a good idea to clean up after ourselves and free up these resources for other services. We'll use the docker stop command to stop the container without deleting it. Okay, so we do that. If we were to list all containers with the docker ps-a command, we would see the stopped container. While stopped containers aren't using memory or CPU, they are still taking up disk space. If you want to clean up disk space, be sure to also delete the container, which we did in a previous lesson. So we don't have to do that ourselves. All right, here we go. Stopping a running Docker container. In the last lesson, we created the daemon mode of the Docker container, connected into it, and have been playing around with it. But we're done with it now. We don't need it actively running. And any actively running Docker container is going to take up system resources. So in this case, CPU and memory definitely are being taken up. Now, if we have a huge amount of memory and a lot of CPU cores, then this probably won't really affect us. You could just run many Docker containers at the same time before you start running into problems. But if you have a older system, if you have like maybe a notebook that doesn't have that many resources, you're going to start feeling that pretty quickly. And so we want to now stop that. And if it's running in daemon mode, it just is sitting there behind the scenes. We might forget about it and not realize that we're running something that's taking up resources. One way to solve this, we can stop the container. So let's run our Docker PS. Here's our Postgres container that we created previously. Now, if I want to stop this, we're going to run the Docker stop command. Let's run that right now. So Docker stop, and then we give it the name or the ID. So in this case, some Postgres. In this case, it just stopped immediately. Sometimes if there's like a lot of stuff that it's doing, it will take a little bit longer. Now, bear in mind that this doesn't delete the container. It's still going to take up disk drive space, but it's now freed up the CPU and memory for other services on our computer. And we can verify that the container is still there with the docker ps-a command. And there it is. We can see that it is exited as of 27 seconds ago. As of this point, if we wanted to free up the disk space that this container was taking, we could delete it, which would then free up the disk space as well. But we already did that in a previous lesson, so I don't need to show you that here. And that's it. That's all I wanted to show you is just how to stop a running container, especially one in daemon mode. So hopefully this is helpful, and I will see you in the next video. Bye. All right. I've gotten tired enough that I'm noticing the desire to keep on talking and just start like repeating myself in the lesson. I have to like spend energy to like not do that and like be more succinct. So it's something that I remember learning when I was doing teaching. My boss took me aside one time. He's like, okay, you've done all these good things. Now you need to learn how to stop talking. Because he's like, okay, like there's this point when you're giving a lesson or you're giving a speech or something else, when you're like, okay, you get everybody, they're going up, they're following, everything's good. And then there's a point where you're at the cap. You're at the top of the mountain of like, you've done everything awesome. Anything more you say just is now down and you're losing them. And I guess my natural instinct is just to talk too much. So I do try to like remind myself to be more succinct, which the more tired I get, the more hard it is to remind myself of that. Okay, start a stopped Docker container. All right, start a stop Docker container. Objectives. By the end of this lesson, you will be able to start a stop Docker container. Content. Previously, we stopped our Postgres database container. What if we wanted to restart it again without having to create a new container? We can do this with the docker start command. This command requires that a container be created but not running. So we show that's not running, docker start some Postgres, and now it's running again. Since this container was started in daemon mode, restarting it will put it right back into daemon mode again. Might want to emphasize that it starts the entry point again. Does it start the entry point again, or does it just resume exactly where it left off? It's actually good. I don't know. This is really helpful. This tells me nothing about what is actually happening behind the scenes. Okay, maybe manual will help. This is in reference still. Okay, how about stop? Maybe stop will have something? Well, I am not going to reference. I'm not going to talk about it. I think we can get away with just saying it restarts a container exactly where it was previously, because as far as we are concerned, that's exactly what happens. Because if we somehow manage to stop the Postgres from running, it crashes it. So yeah, here, let me find out. Because now I'm interested. What did I do wrong? Docker IT. Oh, exec IT, not IT. Okay. What is it? Is it PS? That was PS. PS is not PS is not found. What's the thing? for what services are running. I thought it was PS, but maybe not. There is top. Oh, apparently there's no top in here either. Okay, cool. Oh, that's what it is. There's just they Postgres default container image just doesn't have any of those things. I'm getting distracted by a little dark spot on the rug down here, and I keep on thinking like maybe it's a spider or something just like staring at me. I'm gonna investigate to assuage my mind. It was a bunch of Zilby hair that had that was somehow just sitting right there, like in a condensed little ball. So that's gone now, and now more hair that he won't just eat on his own. Okay, so now if I can I kill all Postgres? There's no kill all. How do I find the process ID? Is kill? Yeah, okay, so there is a kill. Okay, so is there PG? Can I like turn it off or kill it somehow? Right, but here's the problem. PS itself is gone. There's no, I can't do PS-EF because this container doesn't have it, which is hilarious. So I would need to install PS to then run PS to find the process ID. Postgres did a pretty good job at stripping away everything that I guess like what they, I wonder if they're based on Alpine. Is apt here? Oh, they're Debian based. Okay, so it is apt. It's not whatever the other one is. Okay, so Postgres help. Can I like tell the daemon to stop? Not that I know of here. You know what I could do? This is gonna be some like the first thing that I usually come up with is gonna be like the old sysadmin way of doing stuff, which is not always a correct way of doing it, but is sometimes a really fun way of doing things. Okay, so it stores its data in varlib PostgreSQL data. So, for example, if I cd into varlib PostgreSQL data, here's all of this stuff. Now, let's say I this might not be a good. This would, if I were to mess with this, it would crash. It would crash out, but that's not really help. That's not necessarily what I want to do. It's like what I really want to do is like stop the server, like temporarily. and there's no like PG. Is there, I don't see like a Postgres database. Is there, can I just do like stop? The server must be started under an unprivileged user ID to prevent, oh, interesting. Okay. Cat. So, okay, so they have a Postgres user ID. So I can do switch user to Postgres. Now can I do Postgres stop? Okay. User lib PostgreSQL 16 bin Postgres. Okay. Oh, check my path environment. Yeah, so I have this. So user lib PostgreSQL 16 bin. Wait. I thought. So Docker stop sends a sig term to the main process in the container, which means if you want to start again, it has to start the main process, which would be the entry point. Okay, so that, I guess that does make sense. I was seeing if maybe I can like manually send a PS. Okay, so let's exit out of here. I have user local bin, user sbin, user bin. Is it an Etsy? Etsy bin? Is there an Etsy bin? No, that's just the things. I don't know where PS normally would be on a system. How would I send a sig term? Oh, you think, oh, it's slash bin, right. Bin, oh, PG. Oh, but there's no PG. There's a bunch of other PGs here, though. And there is no, yep, there is no PS. Sig term can be sent with kill. Okay, perfect. Now, if I could figure out what it was running, but maybe also we could do PG. No, I don't see anything for like a Postgres to like stop. Yeah, okay. Don't think any of these things will help me out here. And kill is great if I knew what I was trying to... Okay, so what if I try to do this? Kill... We could install that. I could just do apt. We could here, let's do this. apt, we have to apt the update first. Kill default to sigterm, but you do need the process, right, which is why we need to install proc ps. Okay, so we'll do an apt, is it info or is it search? I don't remember anymore. Search proc ps. Proc file system. Okay, so we want to install you. Go ahead. Okay, so you're good to go now. Oh, okay. So ps ef. Okay, so here's Postgres. PID 1. That's impressive. Okay, so if I do kill Postgres, sorry, kill 1, that crashed and took me out of the container. That crashed the container. Interesting. Okay. Right, because it was running up and running from that only. Yes. Okay, so we're done there. Now if I do a docker ps, we're gonna restart this. So docker start some Postgres. The only reason it can remain up. Oh, run docker top as well? Yeah, I don't think I've actually done it before. That's pretty cool. I did not put this into the course. Docker cause some Postgres. We could have just done that. Oh, interesting. Look at that. So its PID went from 1 to 3808. So it did relaunch it. Yeah, Docker top would have been a lot better for us to use. It didn't have top inside of it, but it knows how to run it because it's running from outside top into top. It's, you know, it's an entire thing. Okay. So this is good. The answer is yes. Whenever we run docker start, it reruns the exec to restart the container, which feels like it's exactly where it left off, but it's actually relaunching whatever the container was. So it's not a true sleep. That's like a little lie. Okay, so we haven't done the video yet. So when I start, I'll be able to say like, okay, what this really is doing is it's rerunning the command that the Docker container was set up with. Same file system, but new processes. Yes, exactly. Now I should be able to just Docker stop this again. And we're back to this. Start to stop Docker container. Okay, we're ready to go. Here we go. In the previous lesson, we stopped a Docker container that we had up and running to save some system resources. But let's say it's the next day, we want to get back to work and we don't have our Postgres container running. We can see that it still exists with the docker ps-a command, and it was exited. Well, we want to restart it. So, well, we can do that with the docker start command. To run it, we're just going to do docker start and then either the container ID or the name of the container. So in this case, some Postgres. Now, if we run our docker ps command again, there it is. That's our Postgres container is back up and running again, ready for us to use. Now, behind the scenes, what's happening is Docker is rerunning the command that the container was, well, that the image is set up with. So the image, whenever we create a container, says, okay, run the Docker daemon command, which starts the Postgres process, and it goes up. So my my metaphor of using or simile of using a sleeping computer is like only kind of correct. And here's where we have to sort of like move a little bit beyond that, because when we stopped the container, it actually halted the process. It turned off the database. It didn't just sort of halt it in time, it actually shut it down. It's more equivalent to a shutdown of a computer as opposed to a sleep of a computer. And then the start is like restarting it back up again, where it relaunches it, it gets a new process ID inside and everything. But beyond that, it's sort of exactly what you expect it to. We can turn on a container back again, and it's pretty much exactly how we left it off previously. Postgres in this case is back ready for us to use again. And that's it. We're ready to go. Thank you so much for watching. Hopefully this was helpful, and I will see you in the next lesson. Bye. All right. Easy enough. Last one of this section. Set up VS Code to work with Docker. Oh, and this one is super simple. Okay. And then we have our content. So yeah, nothing really special there. I didn't have enough to even make a spelling mistake. Okay, set up VS Code to work with Docker. Objectives. By the end of this lesson, you will be able to set up VS Code to work with Docker. Content. VS Code is a really nice extension that allows devs to work with Docker seamlessly. The extension is simply called Docker. Note that if you don't use VS Code, you aren't missing anything. This extension allows devs to graphically manage Docker. If you use VS Code and you want to use VS Code to work with Docker, install the extension and also watch this tutorial video to learn how to use it. So pretty much I just punt and say, go there. They did a much better job. This tutorial video is actually on the official Docker. I think it's the official VS Code channel for YouTube. I don't remember anymore, but it's some official looking thing, and it should be fine. But we can still do our own lesson for this. So, and then from now on, I think all of our lessons are going to be within the context of VS Code after this. The profile that I'm using, Docker for web development. Can I clear a profile? I don't think I can, right? I kind of want to delete it. And we're going to create a new profile again. So I'll call this introduction to Docker. Each time I did that, the font got smaller, that's fun. Okay, so here we are in Docker. I guess this opened up this specific, can I have you not? Sure, go ahead and install an update. There we go. Okay, so we don't have any folders yet. We have a brand new VS Code. We're connected to the introduction to Docker profile we just created. So there's no extensions or anything else set up for this. So we are going to install the Docker container, and that will allow us to sort of do things with it. So and then I think I'll just sort of go do a quick walkthrough of it. So that'll be fine. And then you're here right there. Okay, we're good. We're good to go. 12 minutes until the next ad break or so. No, ad break starts in 7 minutes. I feel like the pre-roll off and the ads are not always, like, they're often like they start together and they sort of get off sync. But as long as there's no pre-roll ads, I'm happy with that. But okay, let's do this. Set up VS Code to work with Docker. If you use Visual Studio Code, the editor by Microsoft, then there's an extension that will make working with Docker really easy. Let's go ahead and set up VS Code to work with the Docker and connect to the image and container that we already have up and running. Now, this is a brand new profile that I've set up, so there's absolutely no extensions or anything else installed right now. We're starting fresh. So we're going to come over here to extensions. It's already in the recommended for us, which is this Docker here. And this was the one by Microsoft. So I'm going to go ahead and install this. And this adds in a Docker section to VS Code. So we're going to click into here. And this allows us to see what containers that we have and what containers they have running. So this is the equivalent of the Docker PS command running basically just all the time for us. And if we don't see our container, we can just run a refresh here. We also can see the images that we have set up here. We can connect to like custom registries. I think by default it connects to Docker Hub. I don't actually really care about the registries for this, so I'm going to close that down. And we haven't covered networks or volumes yet in the course. That'll come in the future, but this this extension does allow us to investigate and deal with those and manage those. Okay, so previously we've basically done CRUD operations on Docker images and containers, and so you basically create, read, update, delete on them. And we can do the exact same thing here. I can stop this container, so we can right click this. I can't make the interactive little menu bigger, but it basically allows me to view logs, attach a shell to it, inspect it, to stop it, to restart it. So I can, like, for example, stop the Postgres container, which then stops, and then I can restart it again. For images, I can right click and remove the image too. I can also attach a shell. So this is the equivalent of that exec command with the bin bash. So if I do attach shell, it opens up a terminal for me and then attaches directly into the container. And now I'm just in here. And if I wanted to do that again, I can just attach another shell, and I have 2 shells in here now. So if you don't have VS Code, it's perfectly fine. You're not really going to miss anything from this because the extension is really just doing anything that we can do from the command line. It's sort of like installing a graphical editor for GitHub or Git. It allows you to do the exact same things you can do with the command line. It's just more of a visual way. So if you already use VS Code and you want a more visual way to sort of see and interact with your Docker images and containers, then this is an excellent way to do that. Otherwise, don't worry about that. It's not necessary to install VS Code just for this. And that's it. I just wanted to show off like what this was and how you can use this extension to manipulate, see, and investigate your own Docker containers and images. Thank you so much for watching, and I'll see you in the next video. Bye. All right. Yeah, we did that in like less than 10 minutes. That's good. And that is all of the videos for first steps. Next up, deving with Docker. We have a break coming up in a few minutes, and I think I'll probably take that break too because I need to re-up my my drink, and I've been talking a lot, so my voice is starting to get tired already. But let's see. What have we got coming up? We have example Express CRUD project. We can go ahead and set up the objectives part of this. So this one doesn't really have any objectives, does it? I'm going to ignore that to sort of show that this is more of a prep thing for everything else. Because we're not going to do anything with this. I just want you to clone this down. Okay, perfect. I guess we could spell check it. This is what? Express CRUD project. Ooh, is it GitHub with a capital H or not? This spell check seems to think that it's lowercase h. Literally does not say GitHub anywhere here at all. Oh, here it is. Okay, GitHub capital H. Okay, so I want to I it. Okay. What was that? There's no saving that's happening there. Okay. We want to reload you. Should change you. Okay. We're good to go. All right. Ad break is starting right now. So I'm going to go ahead and take my break alongside that. And I will be back in a few minutes and we'll read through this and then do the video on it. So I will see you in a few minutes. The urge to hit escape WQ gets stronger over time. It does. Absolutely does, especially the more tired I get. All right, I'm back. That took a little bit longer than I expected, because when I was upstairs getting some water, Sylvie came down and pressed the food button, and I'm legally required to respond to the food button whenever he presses it. So I gave him I gave him some more food, and he was super happy to get that. He looked like he was going to follow me back down here, but I don't think he did. So I can't really show him too much on stream anyways, because we're doing so many recordings. So that's another thing altogether. But let's see. We're continuing on. Okay, so Express CRUD project. We did our spell check of this already, so we're good to go. Express CRUD project. We've created a simple Node.js Express project that we can use for example purposes. You can find it on GitHub at blah. Git clone this to your local system with git clone. Okay, blah. While this project requires Node version 20.x and a Postgres database, it is meant to be used in conjunction with Docker, so you don't need to have Node or Postgres installed locally. Before continuing on, please clone this project locally. You don't need to install Node or Postgres. I was worried that like people would actually just install it just to make sure it's working. I only want them to run this. Okay, so I guess I don't need VS Code like that. I do want to go to here to look at this. Okay, this is good. All right, Express CRUD project. And then we'll come here to look at the Express CRUD project. And then so we can just grab you. And then we'll come to here. Where do I want to put this? Because I actually have this cloned on my system. I guess I could put it on my desktop. I don't really like to encourage people to put this type of stuff on their desktop, so maybe do I have a scratch? I'll put it in playgrounds. That makes sense. Okay. All right. Here we go. Express CRUD project. For the next section of this this course on Docker, we've created a Express CRUD project that we're being running as if it was something that we were developing or had maybe taken over as a project in our work. And we need to run this locally to get it running, to do things to it, or whatever we feel like. So we don't need to write the project ourselves. We already have it written up for us. So here we have this Express CRUD project here in the lesson contents. There's the URL to it. I'm going to go ahead and clone this project locally. So we copy you, switch to you. I'm going to go into my code, playgrounds directory and git clone u. All right, so this installs the Express CRUD project. We can cd into it. Now note that this project itself is written in Node.js. It requires Node.js version 20, and it also requires a Postgres database. That being said, there is no need for you to install Node.js or Postgres locally to run this. We're going to do all of it inside of Docker. And that's it. That's all we need for this specific article lesson. We're not really learning anything here. We're just prepping ourselves for what's to come. So with that, thank you so much for watching, and I will see you in the next video. Bye. All right, simple enough. All right, what are we doing here? We mount, okay, so we mount a directory on our computer into a Docker container. And I think that's it. This is share code. Okay. Vinox, hello. How are you doing today? Will this be a free course? I don't think so. I think I'm gonna charge more than the SQLX course, but not like a huge amount. The free version, so to me, like the free tier is essentially going through the VODs here, since I am gonna put, since these VODs are gonna be on YouTube. Does that answer the question? Like, so yes and no? The actual like nice where you get the articles and like a nice where you can actually see and read through the articles on your own is going to be on the paid course. Right now, I'm thinking of like 25 or so US dollars. I don't necessarily have any market research on like specifically Docker courses for what this will be. So like maybe I might do a little bit of that once I complete it and then like adjust that accordingly. But like I know like some courses are like some people are charging for like, you know, various courses like $100 USD or so. And I don't think this is going to be that much. Yes, I can link to the SQLX course. I should create a command for that. But for the LMS itself, here is the SQLX course, which I'm charging $5 USD to. And then this same LMS, it's going to be just another course that I put in here. This is where the Docker course will be, that you can eventually buy it. It's not in there right now because I'm still like building it out. I'm going to have to upload all the things into it. And then you'll be able to purchase it. But yeah, so let's see. How is the payment process? Can you easily buy it from Germany with euros? Yes. So I use, my account actually owns it. I have two accounts that both own the course, so I can't actually show it off that easily. Plus also it might like show off my credit card information, which would be bad. I use Stripe as the payment processor, and I clicked the box to allow paying in your local currency, which Stripe claims that they have like 100 different currencies that they allow this in, and euros in Germany is absolutely, that's going to allow you to pay in euros and not have to pay in USD. Now it doesn't move down to like the equivalent of 20 in your local currency. It does the equivalent. So whatever, like if for example $5 is like, I don't know what it is, like let's say it's like €6 or something like that. I don't know what the exchange rate really is right now. Then it would be €6 for you. So it's still the equivalent to whatever $5 is at the moment that you purchase it. And of course, if there's a problem with purchasing, the best way, like there's several different ways to get in contact with me. I don't have like a help in here yet, but Discord is probably the best way right now. And I do have a link to Discord on the homepage to join the Discord community. And I even ask you to give me your Discord username so I can add you to like a course specific Discord thing. You have no credit card. They're not that common here. What way, if you could pay for it, what way would you choose? Because I certainly would not want, like if you wanted to purchase something, PayPal. Okay, I am going to add that in. Let's see. Add ability to use PayPal to purchase course. Okay. I have never worked with PayPal, and I don't even have an account. Or I think I have an account, but it was years ago, and it's not associated with Brooks Builds. So I need to do that. I'll have to figure out how that works. I know that a lot of people do have PayPal stuff set up, so it shouldn't be that hard. I just heard Zilby meowing a lot. I think he wanted me to go up to him and do something. Maybe play with him or hang out with him. Or maybe just, oh, hey, Zilby. You're here. We have Kitty Cat. Oh, absolutely, Venox. Glad to help out and answer any questions. All right. Are you just leaving now, Zilby? Oh no, he's gonna hang out with us. Okay. Well, we can have Cat Cam on for a little bit of time. I have to turn it off for the recordings though. Okay, so let's see, where are we? What's up? Yes. Is there anything interesting over here, Zilby? Usually when Zilby starts exploring like this, it's usually because he's hungry. But I just fed him, so I don't think it's that. He might be bored. That might be what it is. All right. I don't think we changed anything. I'm going to do a reload here anyways, just in case. Okay. Let's read through this and make sure it's what we expect. We're starting here. We're getting into a lot more interesting things. Oh, you want fun. You want fun. Hold on. I have fun for Sylvie. And switch to except no break. What I like to do is put some of his toys and soak them in catnip. All right, you want this? Let him go play with that a little bit. Sweet cat. Sylvie is a sweet cat. He's been pretty awesome as a cat. If you go back far enough on the streams, you might, like from several years ago, you can probably see when he was a super young kitten. A cigar aficionado? I don't think I have anything that was the cigar stuff. Venox, thank you so much for the subscription. Thank you, thank you, thank you. And 2 months in a row. I thought that I had turned off to get the Twitch alerts. But apparently that's not the case. Oh, you thought you spotted a cigar box. No. Let's see, what do I have there? I have I have a board game. I have the board game Seven Wonders Duel, which that is just sitting there. I can't remember why I had removed it down here, but that's probably the box you saw. It does have a cool design on it. I've smoked some cigars in the past, but I'm not really into cigars. I don't own any. Usually it's like when I go visit some people, if they have like a nice cigar, it's like, okay, I'll share one with my wife or something. But I usually don't like, I'm not a big cigar person. All right, I think Zilby just walked away, so I think he's done. Okay, yeah, the box underneath the tissue. Yes, that's the Seven Wonders Duel box, which is a really good game. It's a 2-player Seven Wonders game, which normally, if you've ever played Seven Wonders, that's like a 12-person game or something. Maybe it's an 8-person game. It's a lot of people game, and it's a very long game. And the duel is like 2 people, perfect for couples. We like it a lot. All right, let's do this. Share code with a Docker container. Objectives. By the end of this lesson, you will be able to mount a directory on our computer, so probably in your computer, and your computer into a Docker container. Content. This should be 1. It is possible to develop inside a Docker container, but also use your favorite code editor. We can do this by mounting I guess like R, then it works. Use R. Yeah, okay. I can see it works. We can do this by mounting a local directory into the container when we create it. When creating the container, we can use the -v post dest option to mount a local directory to the destination directory inside the container. It doesn't matter if the destination exists inside the container. If it doesn't, Docker will create it for us. If we give the command a directory that already exists, then Docker will overwrite it with the mount. This will remove access to whatever was in that directory. Be careful that you don't put your mount somewhere important like /bin, which is where basic commands like the bash shell and ls are located. So okay, we have our Docker run, and we're putting things into /code. Note that we use a special shell command, the $pwd, for the first part of the volume. This syntax allows us to run a subcommand in a command, and it will resolve to its value first before the full command executes. We need to do this because the -v option requires a full path instead of a relative one. Since we so often want to share the directory that we are in when we run the command, we've used pwd. However, if you want to share another directory, then just put in the full path instead, like -v/usersbrooks, blah, blah, blah. Okay, to code. By default, the mount is read-write accessible from inside the Docker container. This allows us to run commands that will update files, add new ones, or delete them from the container. Be careful to only share the directory that you want the container to have access to. While it is possible to share your entire computer directory with the container, it is also asking for trouble, since the container could do things like delete everything by accident. You can read more about volumes at the official documentation. Applying this to the Express CRUD project. Let's apply this to the Express CRUD project so we can develop with this code. So I think we just apply this to the Express CRUD project. Since we already have the repo cloned, all we need to do is change directory into it and create the container and share the code. So we just do Docker run, we do the thing, and I do an ls to see the code. We can't run this since the modules haven't been installed. However, we're running this inside a Node.js container so we have access to the correct version of Node. We can install them with the command npm i. Since we're inside the container, we also know that we have the correct version of Node for this project. Okay, so npm i install. If we open our editor of choice to view this code, we can see the Node modules on our system. This means that we can now use our editor to edit the code, but run it inside the container at the same time. Excellent. Am I using a tool to compile your Markdown in a presentation? No, I am not. What I am using is in the LMS, where the learning management system, where this runs. So that would be, that'd be this. Let me go ahead and log in. There we go. So if we go to our courses and I open up this course, all of these are just those markdown files that I have. And it is, what tool am I using? Marked or something? Is basically rendering the markdown as HTML on the front end. So it's happening in your browser. Does that answer your question? And fun fact, for those of you who didn't see, we built this entire thing on stream, which was a lot of fun. I guess like most of it on stream. I did some of it off stream. This is all written in U.rs. So it's all, this is a front-end framework in Rust. So Rust code in the browser, which is awesome. Okay, so I have VS Code closed. So what we're probably gonna do, I want to CD into the Express CRUD application. And so here we're going to do our Docker run command to connect in. And all I'm doing right now is the V command. So I'm not doing any of the ports or anything else. It's just gonna be the Docker run IT. Okay, so we're just gonna be creating a whole bunch of containers in the next couple of lessons, and it's gonna be fine. I'm probably also going to VS Code update. Yeah, we're gonna open this in VS Code too, and then do the commands from there. So it'll be fine. It'll be great. Let's see. So that's good. Let's go and set this up. All right. You know what? I'm curious, for my desktop audio, what devices are you going out on? Where's my advanced? Okay, so desktop audio is going on, oh, tracks. Okay, so if I just do everything but track 2, then you should still hear them when the desktop audio goes, but the recording won't. So if anything else happens, it won't be visually there, and then also at the same time, I will be able to hear it. You will be able to hear it, but the VOD and recording will not, which is nice. Okay. Excellent. Here we go. Sharing code with a Docker container. Now that we have the Express CRUD app installed locally, we want to start developing with it. But we want to like run it inside of a container, but also develop on it, which means that, and I want to use VS Code, which is obviously going to be outside of the container. It's going to be on this side here. Let me go ahead and open up VS Code in this project. So code, open you up. Now, let's imagine that I don't have Node.js installed. I'm going to go ahead and trust the authors here. Let's imagine that I do not have Node.js installed. I don't even know if I have the correct version of Node.js installed. It doesn't matter. I want all that to run inside of a Docker container for this application, which means we're going to have to create a container and then somehow share our code inside of it. And we can do that with the mount command. So I'm going to go ahead and open up a terminal in here, and we're going to run, let's make this a little bit more full screen. We're going to run Docker run. We're going to use IT so we can interactively connect with this. I'm not going to give it a name, so it's a random name because over the next several lessons, we're going to be creating new containers over and over again. And so that's going to be fine. And let's see, then we're going to give it a volume. So the volume is telling Docker to, basically, we're going to mount something inside of the container. And our choice is going to be another container, which we'll get into in a future video, or something from the host machine, which is what we want right now, which is this specific, well, the directory that we're in. And we can see our current directory is my home directory, code, playgrounds, express crud. Now, I can just replace that all with a sub command here, pwd. And this is really important. The $, curly, just normal parentheses. That's how words work, right? And then where it's going to go, which in this case, I want it to go into just /code. I know that /code is a directory where nothing special is. If, for example, we put this into like /bin, where a lot of Linux commands are inside the container, it would overwrite those and replace it with my code here, which means that like things like ls would just stop working because they don't exist in there anymore, which is not great. That's not what we want to do. So please be careful with that. Now, the reason why we have to do pwd here is because we have to pass it a fully like qualified path. Like it has to be like start from /. So in this case, it'd be like /home /Brookzerker /code /playground /express crud. This allows me to just have wherever my current working directory is, I do that. If you want a different directory and you're not currently in that directory, you can just give it the full path. Okay, and then the rest of the command is exactly the same. So I want to now run, this is going to be, Node.js. So I want Node, we want version 20. So we already, the tag want 20 to be that. And then we want bin bash to overwrite. So we just are inside the container. And another way, instead of just pwd, I can also replace this with dot to just be this one here. Okay, let's run this. We're unable to find Node.js locally. We don't have that installed, so it's going to go ahead and pull this image down for us. And once that's done, it will drop us inside. All right, and now we're inside of our container. Let's go and take a look at our code because we're currently in the directory / in the container. So I'm gonna cd into /code. I'm gonna ls, and here is all the files, and we can see these files match up here. All right, so that's great. By default, whenever we mount a directory into a container, it's gonna mount read write. This is really good because now I can do things like npm install, use the Node package manager to install all the packages that are required for this product. And because I'm in the Node.js image, I know I have the right version of Node. So let's go ahead and get that running. So npm I for install. And we also see immediately that Node modules get set up for us here in like the real world, in our actual system. So a command inside the container affected our disk drive out here. So something to be aware of, and this is why you should never mount like your entire disk drive into a container, even if it will make things like a little bit easier, just because you don't want your containers to have access to everything. What if you accidentally did an rm-rf? You can do that for fun in a container, but if you're mounted something in there, bad things can happen. And that's, let's see. I think that's it, everything we got. We have mounted our local directory into the container. We've run it, we're connected in, and then we have access to all of our files. And if we want to make changes to them, we can change them either out here or we can change them inside the container. So that's an excellent, it's an excellent way to be able to develop inside of a container while also, well, having our editor outside the container, like VS Code. Thank you so much for watching. Hopefully this was helpful, and I will see you in the next video. Zorzor, hello. Or I guess it's XOR. How are you doing today? And also thank you for that. I didn't realize that you can do dot. That must be a new thing. So let's update our article. So first of all, I want to do something like, I think I do 3 lines like that. There's a horizontal rule. So thanks for XOR for letting us know that we can use dot instead of the full path. Okay, so somewhere in here, okay, so can also recently Docker updated so that we can use dot instead of a full path if we want to mount the current directory into the container. All right, I want to just grab this. Much simpler. Yeah, absolutely. I'm more than happy to. If you have like a Twitter or something, I'd be happy to also put that as a link for you. Otherwise, it'll just be Zorzor or like Twitch user Zorzor. Sometimes I don't know like how to do that, or like what the standard should be. I'll have to figure something out for that. But community is like a really big like thing to me. So now if like somebody purchases this course and you're like, oh, you're Zorzor, you're XOR they'll like know that you helped out with this. Okay, so that's it. We're good to go. This was 0447. Wait, at Rumpel is my Twitter, and you were the one who implemented the dot for volumes? Oh, awesome. That is great. I think I've only met one other person that I know I've met who was on, like, worked on Docker. So thank you for that. That's a really good feature too. How was it working on Docker? I've only really like done Docker as a user, as it were. Well, wait, I shouldn't, this doesn't make any sense. It's, oh, come on. This, Do I have to log in just to see? No, that's not Rumple. Was that it? Like, I hate that. Working on Docker is great, but also with the amount of users, it can be scary sometimes. You can easily break people's workflows. Yeah, I can absolutely imagine that. Okay, that was okay. So I think that's how it works, right? It's just Twitter, yes, twitter.com/Rumple. Okay. If that doesn't work later in the future, I will we'll have to fix that. But I don't have edit abilities. I have to edit in the database manually if I have to update the course, because I haven't added full CRUD for each article yet. It's not, it works. But yeah, I can absolutely imagine like any of those big projects, like working on Docker, working on Node, working on Rust, like any of those things is like, okay, we're going to change one little thing. And it's like millions of people are going to use it, which is both humbling, but also like, that's something to be proud of. Okay, so after close, we're good there. Okay. Share code with a Docker container. All right. Next up, expose ports between host and container. Let's see. I wonder if this is gonna work. I should probably test this again. I think it should work. All right. I guess as part of the video, if it doesn't work live, then I have to redo some of it. Okay, so expose ports between host and container. Objectives. By the end of this lesson, you will be able to expose a port between a Docker container and your computer. Content. We have a container with the Express CRUD available in it. We can run the application using the command npm start. However, there is a problem. While the program will run, we won't be able to connect to it since it's running inside the container. As far as we're concerned, it's as if it's running on a completely different computer. We can fix this by recreating the container, but this time mapping a port from our host machine to the container. We will need to remove the one we have since we can only map the ports when creating the container. So we do that. Oh, I'm constantly removing this. Okay. Now we're ready to create the container again, this time with the port mapping. We'll use the -p host port container port command. And then I do put in like 3020, so like a different port. I remember in like a previous course that we did, I was always just having everybody use 3000, and then there's some people, there was like some people and then me too. Like it happened to me. It was like I already had something on 3000 and like for some reason it didn't cause problems and allowed two services to run on the same port, which normally should not work, but like every once in a while, the operating system, so like, yeah, that's cool. Go ahead, run on there. And then it routed to the wrong port or wrong service. Okay. We are now able to connect to the app on port 3020 from our computer. In this case, the port in the container that we're expecting the Express app to connect to is port 3000. This would allow us to run multiple containers of the same app, each of them connecting to a different port on our host system. However, we have a problem. The app isn't running on port 3000, it's running on port undefined. We'll fix this in the next lesson. Oh, right, because environment variables. That was the next thing, environment variables. Okay. So actually I don't need, it doesn't matter. It's just running. But we can use the dash ps command or docker ps to sort of see it. All right, so basically I don't need to worry about it running or not yet. Did I run spell check? I think I did, right? Okay, so we have you up and running. This is great. I'm going to quit out of you. Okay, and you go straight into here. All right. Let's do this. Recording time. We're now able to run our code inside of the Docker container and update it from outside the Docker container. But what about ports? Because this is a server and we're going to want to connect to it with our browser, or at the very least use something like Postman or Thunder Client to hit our API to see if it's working. And we can't do that if there's no connection. So we need to somehow mount a port from our system to the container. And we can't do that with the -p command. Let's go ahead and recreate a new container again. We'll do the same -v mount, but we're going to add in the -p to map a port from our, well, host system to the container itself. Let's set that up. So we're going to do docker run. We're going to do IT so I can, connect inside of it. We have our volume mount, so we're going to mount local to pwd. No, local to /code. What was I thinking? Okay, so mount the current directory into /code, and then the new thing here is port. Now I happen to know that the port that this application runs on is port 3000. So I could absolutely just write 3000 and then on our host system and map it to port 3000 inside of the container. But I'm not limited to that because I can set whatever the port is on my host system to whatever I want. So for example, I can set port 3020 on our host system to port 3000 in the container. And this is wonderful because this means I can actually run this same backend app in multiple containers at the exact same time. Let's say I want to test it in Node.js 20 and then Node.js 22. I can run them both at the same time, run tests on them, make sure that they're working the way we want them to, and all I have to do is set them to be different ports to, as I'm testing them out. So I can have like 3020 and 3021. And at the very end, we're going to run this on the image node 20 and we'll go to bin bash. Okay, and this now grabs. We could still run our command here. So if we cd into /code. Now, even though this is a brand new container that we spun up from the image, we don't have to run npm install again because we had already run it previously. And remember that affected the disk drive outside of the container itself, like on our host system. So everything is just still here ready to be run. So I can now do npm start, for example, and it starts our application. There is a problem, which is the server is listening port undefined. So I can't actually hit this yet to validate that the port is running. That will have to come in a future lesson. But let's go ahead and open up another terminal here. We're going to run docker ps. And oh, that's a lovely. Let's make that smaller. I'll make this a little bit smaller so we can see it a little bit easier. We can see here for our Inspiring Hamilton container that we created, our port 3020 on our host system is mapped to port 3000 internally. Compare that with our Postgres container that's still running, which just shows this port 5432. Our host system cannot connect to this 5432. It's just telling us that that port is like available and ready to use. And that's it. We're ready to connect, but we can't yet. We'll fix that in a future lesson. Hopefully this was helpful. Thank you so much for watching, and I'll see you in the next lesson. Bye. All right. So let's see. This is good. I don't need you anymore. Connect out of there. Okay. You love the content? Thank you. I hope that it's helpful. At least with like getting people up and started with Docker. I know that there's some people that get really like overwhelmed with Docker. It's scary, right? And I don't think it deserves the scary reputation. And it enables so much. All right, ad break starting in about a minute. That'll be a 3-minute ad break, but we can work through that. But this might be the last break because my voice is getting tired. And I can feel my brain start to get tired from like all the talking and like thinking about this too. So we'll see how many more we get through before the end of the stream. In the meantime, I am going to continue working through these. Ooh, experse. Let's do one for that one. Oh, that one has a new line broken. Okay, so that's good to know. Oh, 2 of them are broken there. All right. Environment variables in Docker containers. Objectives. Add an environment variable to a Docker container. Content. Environment variables are a great way to add context-dependent data to our applications. For example, when developing, we might want to run the application on port 3000, but in production run it on port 4000. We don't want to hard code these values in, so making them available as environment variables is one of the best ways to go. Without Docker, our choices for setting environment variables are limited. We can manually add them to our shell or the .rc profile, but will those be available to every project we run in that shell? Oh, but those will be available to every project we run in that shell. .env files that get loaded at runtime are very popular, and as of writing this article, Node.js no longer requires a special library to load the environment variables from a file. However, with Docker, we don't need to have either. We can set the variables, we set the environment variables. When we create the container with the -e name equals value option. If we want to have multiple variables, we can use multiple -e options. Let's add in a port environment variable for the Express CRUD app so it knows what port to use to start. Again, we can only add these environment variables when we create the container. So if we have one running already, we'll need to stop and remove it. Okay, so we then Docker run, we do everything the same, but now we have port equals 3000, okay. We can now query the health check route for this app from our, where was the other? We saw two problems. It was right here. Okay. We can now query the health check route for this app from our host computer and see it respond. And so that was one problem. Okay, there we go. That was the two problems there. Oh, no. This one too. I don't, okay. Slash, okay, so they're just three selections. Okay, that that did not do what I wanted to. Okay, let's try this again. I want to search for maybe $. Oh, I could do close. $, space. Close $, 3 sections. Okay, that works. So then you go to the beginning. There it goes. That's a lot better looking. Okay, so now we can query the health check route for this app from our host computer and see it respond. Excellent. So this should work now. All right, so we are going to recreate our container again, but with the environment variable now. XOR, thank you so much for stopping by and the help. And thank you again for helping out with the Docker project. And have a great rest of your day. All right, let's record this. Environment variables in Docker containers. In the previous lesson, we got set up with running the server and exposing the port, but we have a problem. The the server is trying to run on port undefined, which obviously is not a valid port. We need to tell it to run on some port that we want to run it on, which the application is looking for in an environment variable. Now, there's a few different ways for us to set up environment variables. We can set up like a .env file and then tell Node.js to read from the .env file, which it can do natively. We don't need any kind of application for that. However, we can also just set up an environment variable because this is Docker. We have the ability to set that up when we create the container and then have that environment variable just be there. And we don't have to make any code changes. We don't have to change the package.json of how Node.js starts the application. It just is there and ready for us to go, which is the way I would prefer to do that. So let's go ahead and we're going to restart. We're going to recreate the container again. So I'm going to just do an up arrow here where we have our previous Docker run. We're going to come here before we run the image itself, and we're going to add in our new command, which in this case is going to be -e for environment variable, and then it's going to be key value. Now, I happen to know that the port environment variable is, well, just all uppercase port. So PORT equals, and then it's looking for a number of some kind. Well, we've already set up that we're looking for port 3000. Obviously, this is us setting this up. We can set this up to be whatever value we want. So I'm just going to say port 3000 here. And that's it. That's the only change I need to make. And now this Docker container should properly listen to the correct port. So we're going to cd into /code again. We're going to run npm start. And it's now server listening on port 3000. So it has access to that environment variable. Let's go ahead and open up a new shell here, and we can now hit the health check. Because if we remember, we are exposing port 3020 on our local system into port 3000 in the container. So I should be able to hit, we're going to do a curl. HTTP curl does a get by default, and the health check is a get. So HTTP localhost port 3020 health check, and we get this back, status I am healthy. So we're now able to connect into the container from outside of it and access our API that's running inside of there, which is excellent. This is pretty much one of the last things we need to do to actually be able to run our code in there and then use it. So with that, thank you so much for watching. Hopefully this was helpful, and I will see you in the next video. Bye. All right. Set the working directory when running a container. Oh, right. We can do that. Okay. I also see a bunch of these code things. I want to get rid of those too. Seven selections. That looks like the right ones. Okay. All right. I think we're good there. This is set working directory. Okay. Let's see, if I reload, I kind of don't think I had anything else special in there. I think we're good to go. All right. Set the working directory for a Docker container. Objectives. By the end of this lesson, you will be able to set the default directory when running a Docker container. Content. So far, we've been running the Docker containers in interactive mode, but this is taking up a terminal window. We already know how to run a container in daemon mode, but we need to run the npm start command in the /code directory in the container when it launches. We can easily run the npm start command by replacing the /bin bash when creating a container, but we wouldn't be in the correct directory. However, we can tell Docker which directory to use by default with the -w option. So then we do that. And then we can just immediately go straight to the curl. This allows us to switch to -d for daemon mode and run the code whenever the container starts. We've added a command in a package.json which will auto restart the server when the code is saved. We can run it with the command npm run dev. At this point, we could continue working on an application and we wouldn't need to manually remove and recreate the container. All right, perfect. We're getting to that part where like really cool stuff. And I guess it's all been cool stuff, but like truly like now you can just start deving and you're not getting annoyed by Docker anymore, hopefully. I did escape as if I was going to do a :w. Okay, so we're going to do that. I don't need this terminal up anymore. So we're just going to run this again. But this time we're going to make that change. So it's -w for working directory of where to go and then npm run start. Got it. Let's do this. We're almost ready to begin developing, well, if we were developing on this project, for real inside the container. However, there's a few things that make this really annoying as a developer. For instance, every time that we make a change, we need to switch over to our terminal, stop the server, and restart it again. Now, there are some commands to automatically restart the server for us, but what if we wanted to run that straight when we create the container and not have to recreate the container, not even have it take up a terminal? What if we wanted to run it in daemon mode? Well, we can do that, but there's a few different problems. Let's first set up what we want to do and then update the command so it actually just works. So I did up arrow. We see the command we want to do. Now, instead, I don't want to do this bin bash. What I really want to do is the npm run dev. Now, there's a script in the package.json command that will, when we run this, automatically restart the server every single time we make a code change. The problem being that I have to cd into the /code directory inside the container in order to run this. And we know from having connected into it that we can't do that. We start in /. So we can use the the -W option here to set the working directory, which is going to be the default directory that whatever this command is afterwards runs in. So let's do that now. We're going to do -W/code. And now this npm run dev command is going to run inside of the code directory, which is perfect, which means I don't need to run this -it anymore. Now this can be -d for daemon mode. Let's go ahead and try this out. So I hit return. Our application, our container is now running. There's the ID for it. And I should be able to hit the health check again. So we're going to do our curl command again. Curl HTTP localhost port 3020. Go to the health check, and there it is. I am healthy. Now, what I could do is come into our code. Let's find app.js. And here is that I am healthy message that we get for the health check route. I'm just going to add in a few exclamation points, hit save, and hit our curl again, and there we go. We see I am healthy exclamation points. So at this point in time, I could now develop on this app. I can just continue working on it. We can do bug fixes, whatever we want to do, and then just immediately use it. I don't have to worry about restarting the app or anything else. It just does it for us in the container behind the scenes, which is kind of where we want to be when it comes to developing inside of a container. And that's it. That's all we were showing in this this lesson. Hopefully it was helpful. Thank you so much for watching, and I will see you next time. Bye. Hungry Bear Dev, hello. How are you doing today? We're doing video recordings today. So when I'm in the middle of that, that's why I couldn't say hi. All right, so to you. Oh, viewing Docker container logs. Nice. All right. I guess like view logs, view Docker container logs. I don't think there's anything else. So it's 11 selections, but I think, oh no, I have more stuff. So I want maybe the $2 to 3 selections. That looks a lot more appropriate. Ooh. which gets us more information. Okay. From the connects. I think that's go ahead and add that to mine. All right, there we go. Viewing Docker container logs. Objectives. By the end of this lesson, you will be able to view Docker container logs. Content. Over the previous lessons, we've set up the Express CRUD project inside a Docker container as if we were going to develop it. And everything seems to be working so far. But we're going to run into a problem as soon as we attempt to hit a route other than the health check. So I attempt to then curl into then get tasks, unable to acquire a connection. When we attempt to get all the tasks, we get this unhelpful error in response. There might be a better error in the logs themselves, but those are console.logged out, which we can't see since the container is running in daemon mode. We can see them by running the docker logs command. So docker logs, we go into the thing. While the message is the same, we can see the stack trace, which gives us a bit more information. The error is coming from the connects library and is complaining about not being able to acquire a connection to a Postgres database. We don't have a Postgres database, which would explain why the app is unable to connect to one. If we want to watch logs as they come in, we can use the docker logs-f option to follow the logs. This is a live view, so as this is a live view. This is a live view. As more logs are written, we'll see them immediately. In the next lesson, we'll create a Postgres container and connect it to the node container running our app. So that everything can work as expected. Okay, excellent. All right, I think the next one is going to be really long. So I think this is going to be our last one for today because my throat is starting to feel it, and I also feel myself getting tired, especially like with I'm noticing I'm writing things wrong. So that'll be good. But I think we did a lot today. Okay, so we're gonna leave. Okay, this container can keep up and running, and we'll continue on with what it is right now. So this will be good. So let me just update you. And I think we're good to go here. We're just going to do Docker logs. For this application, I have a whole bunch. Oh, we only have that one up and running, so that'll be fine. Okay. Do make you small enough that you can see. Okay. That I can see at least. All right. There. That'll be good. Okay. So just logs. Oh, and I want to go to curl localhost 3020 tasks. Excellent. All right, let's do this. Last recording of the day. So far, we've got ourselves set up so we can start developing on our application. But what happens if we need to view the logs? Let's go ahead and set ourselves up in a situation where we kind of need to. So in this case, we still have our container running in daemon mode. It's auto restarting whenever the application changes. Let's go ahead and hit it with a route that should do something, but it's gonna fail. So we're gonna do a curl to HTTP localhost 3020 tasks. And we get this not super helpful error. So error unable to acquire a connection. What does that exactly mean? Well, maybe there's a little bit more information in the logs themselves. And now in this case, the application is console logging to standard out or standard error. I believe in this case it's standard error, but we can't see them here because our container is running in daemon mode. There's just, it's going to something. But we can connect to the container and look at the logs with the docker logs command. So we'll do docker logs. Now, the problem is we need to know which container it is. So we first need to do our docker ps and see that our Node.js image is currently named Serene Pair. So I'm going to go ahead and copy that and do docker logs Serene Pair. And we can see here's our problem. Unable to acquire connection, client PG. Okay, so this is going to connects. Okay, this is connects is attempting to connect to a PG or Postgres database and is unable to. Well, it's probably unable to because we haven't actually set up a Postgres database to connect to the Docker container. So there is no database for it to connect to. That would kind of make sense. Now we can also set up, like if we want to follow the logs, like let's say, we want to try this again just to make sure that that's really the problem. I'm going to do docker logs -f for follow. And now it's taken over our terminal and this will auto update. So I'm going to hit return a few times. That way there's a gap. Let's open up another terminal window over here, and I'm going to use our curl command for, let's see, 3020 to tasks again. And we see, okay, there's our logs immediately print out again. We know exactly that, well, we now know exactly that this is what's causing the problem, and we can recreate it whenever we want. So that's very helpful. Now, for solving the problem of connecting in, we're going to do that in a future video. So with that, but this is how we can actually, connect in and view the logs. Hopefully this was helpful. Thank you so much for watching, and I will see you in the next video. Bye. All right. And that's it. I just tried a -D to go down, but that just goes down. It's not like actually closing a container, so I'm definitely tired. I lasted for 5.5 hours on this stream, which I think is pretty good. And we got more than halfway done. Look at all these videos we did. So all of the getting set up with Docker and almost halfway through deving with Docker. So coming up next time, which is going to be tomorrow, because we're done with our TIS 100. So we're now going to be doing just more Docker stuff tomorrow. Connect to, let's see, we're going to connect them with the network. So we're going to create the Postgres container. We're going to add it to a network. We're going to put it on there, and then everything is going to work then. So our application is finally going to work starting with the next lesson. We're going to have persistence. We're going to have data volume stuff. Then we're going to get into Docker files. So fun stuff. It's going to get more complicated starting next time. Kesor, hello, how are you doing today? But after TIS 100, don't you need to finish Exapunks first before you start actual work? Yeah. I actually don't own Exapunks, but it's on my list now. But yeah, I have a list of like 6 games to like play as part of the stream. I know you want it. The plan. So here's my idea of like what we do. I start a project, a course, and a game all at the same time, and they're different. Or maybe I don't know. That's what we did this last time. And then as each one finishes, just the other day is like sort of jump on to do them all together. I don't know if I'm going to do that next time. Like I might just do like, you know, first 2 days and then the game, or maybe just all 3 days we do as the game. I'm not sure. But it'll be fun. I don't know if Exapunks will be next. What I'll probably do is roll random dice or whatever and choose which one. I know. I do want it. I do want to play a game. It'll be fun. But I also want to get a course out. So it's, you know, one of those two things. Okay, so you're good. Go ahead and quit out. We did. Look at all these things we updated. That's awesome. Okay, so that's pushed up. I did not finish Shenzhen.io. I played Shenzhen.io. Did I play that on stream? I don't even remember if I did play it on stream. Did I even upload it to my channel? I don't know. No, I did not. I think I may have played it on stream, but then I didn't upload it. I didn't archive it. So I think it's just gone forever and no evidence that I ever did that. And probably with, let's see, these are more recent ones. Do I have like the really old ones? No, I didn't do the original TAS and the original Shenzhen.io gameplay stayed on Twitch and probably just auto-deleted after a while. There's no evidence that I've ever touched them in the past. It's going to be completely blind when we eventually go through it and do it in the future. So that'll be fun. Ooh, Zachtronics is releasing a couple new games soonish. Ooh. They haven't done anything in a while, have they? So that'll be fun. We should take a look at those when they come out. Assuming they're following the same pattern. Okay. That being said, I think we're done here. I'm going to keep the recording videos Nightbot mod auto message on because tomorrow we're going to be doing more video recordings for Docker. Last call BBS. Oh, it's going to be a virtual BBS. That's going to be interesting where we're like dialing into a BBS and doing something. There's so many interesting things that can go. My immediate idea is to think of the Hackers game, which I forget what that was called. That one is already released. There was another one. Okay. I haven't played very many of their games. I have played like TIS 100, a little bit of Shenzhen, a little bit of Pharma, maybe one other. But I've never, like, TS is the only one I finished. So I want to get more games finished. That'd be, again, more fun stuff. But work first. Okay, so Molex Syntax. Syntez. Well, I haven't even heard of that one at all. That's the new one that's coming out soon. I wonder what that one's going to be about. It will, we will save that for when they release. Nope, that's also 2019. Okay. It's about chemistry. Well, Pharma was about chemistry too, but it's, yeah, interesting. We'll have to, well, all more things that we can check out when we get to them. That being said, I am tired. My voice is tired. I want to stop talking and like rest my brain. So I'm going to go ahead and call it for a day. Thank you everybody for hanging out. We went through a lot of videos today, and I don't know if we're going to finish all the videos tomorrow because they're certainly going to get more complicated and longer, but I would guess that we're going to get, if not all of them, a pretty good chunk of them, hopefully. And then I could imagine that we're done with like the recording of the course next week, by the end of next week. So that being said, I hope that you all have a great rest of your Tuesday, and I will see you next time, whenever that is. Have a good one, and bye.